Jupiter is easy to recognize from far away. A striped sphere, a red wound in the clouds, a planet so large it feels less like a world than a place where scale itself has gone wrong. From a distance, it looks almost understandable. That was the illusion, because the real mystery of Jupiter was never the beauty of its cloud tops. It was the quiet assumption hiding inside the way we looked at them. The assumption that beneath a visible surface, there must be a cleaner answer, a structure, a center, a more stable truth waiting underneath the turbulence. NASA sent Juno to test that belief. Not symbolically, physically. It was sent to go under the clouds without ever touching them, to read what sunlight could not read, to descend, not with eyes alone, but with gravity, microwaves, magnetic fields, radiation, and timing so precise it could detect the faintest distortion in a spacecraft's motion. To take a planet that had lived for centuries as an image and force it to become a mechanism. And what Juno found was not just strange, it was corrosive. Because the deeper Jupiter became visible, the less it resembled an answer. That is what gives this story its pressure. Not that Jupiter turned out to be dramatic. We already knew that. A planet this large, this fast, this electrically violent was never going to be calm in any human sense. The real shock was that once we began to see past the familiar image, the categories themselves started to fail. The core was not what a core was supposed to be. The magnetic field was not behaving the way a planetary magnetic field should. The storms were not shallow decorations painted on the atmosphere. Even lightning and water were turning up where old intuition said they should not. Jupiter did not hide a simpler world beneath its clouds. It hid the breakdown of simplicity. And that matters for more than one planet. Because Jupiter is not just the largest world in the solar system. It is one of its deepest archives. It holds an enormous fraction of the matter that never became the Sun. It preserves, in compressed and convecting form, information about how giant planets form, how heavy elements mix, how interiors behave under monstrous pressure, how magnetism rises out of conductive fluid, how weather stops being weather and becomes part of a planet's internal life. If our picture of Jupiter is wrong, then some part of our picture of planetary reality is wrong with it. This was always the deeper wager of the mission, and even before the first measurements came back, there was something almost fitting about the way Juno had to approach its target. Jupiter does not allow easy visitation. It sits inside an environment so hostile to machines that distance is not safety, only delay. Long before any probe reaches the visible clouds, it is entering a kingdom of trapped particles, accelerated to brutal energies by a magnetic field so immense it carves out a cavity in the solar wind millions of kilometers across. Near Jupiter, space is not empty in the peaceful sense. It is crowded with invisible violence. That matters because spacecraft are fragile in ways that planets are not. A burst of radiation does not have to be dramatic to be destructive. It can move quietly through metal, through insulation, through silicon. It can flip a bit in memory, corrupt a command, blind a detector, degrade a sensor one microscopic injury at a time. Enough of that, and a spacecraft does not explode. It simply begins to forget how to be itself. So even reaching Jupiter with a functioning scientific payload was never a matter of crossing distance alone. It was a matter of enduring a place where the local physics actively works against observation. And Juno had to do this far from the Sun, where solar power weakens into a thin and reluctant trickle. Near Earth, sunlight feels abundant, casual, almost free. Out near Jupiter, it is rationed by distance. The Sun is still blinding if you look at it, but its usefulness has thinned, its pressure has relaxed, its warmth has withdrawn. Solar panels there are not symbols of abundance. They are vast black wings catching what little remains. Everything about the mission carried that contradiction. Distance without emptiness, sunlight without generosity, approach without safety. Even the way Juno moved was an admission that Jupiter could not be met directly. It had to be thrown outward by the energy of launch, then sent looping through the inner solar system, then brought back past Earth for a gravity assist, borrowing motion from one world to reach another. Years passed before it arrived, years of flight through cold darkness toward a planet that, in the imagination, seems almost theatrically obvious. A giant striped ball, impossible to miss. But seeing Jupiter is easy. Interpreting it is the hard part. That is the deeper pattern that runs through all of planetary science. The more familiar a world appears in images, the more dangerous it can become as an object of thought. We are seduced by surfaces. Mars looks like desert. Saturn looks like elegance. The Moon looks dead. Earth looks stable. Jupiter looks like weather wrapped around a sphere. The eye gives you a shape, then intuition starts lying. Because a visible surface invites human habits of reasoning that may not belong there at all. We think in layers because that is how many earthly things work. We think in shells, crusts, atmospheres, boundaries. We think the outside is the mask and the inside is the truth. We think depth is clarification. That assumption feels so natural we barely notice it. Juno was built to test whether Jupiter obeyed it. Its instruments were not designed merely to admire the planet. They were designed to violate appearances, to map gravity so precisely that hidden mass distributions would betray themselves, to listen to microwave emissions rising from deep below the visible cloud deck, to trace magnetic structure with enough accuracy to watch the planet's interior express itself in field lines and asymmetries, to study auroras, plasma, radio emissions, atmospheric chemistry, and the invisible geometry of forces that the human eye would never detect on its own. In other words, Juno was not sent to look at Jupiter. It was sent to force Jupiter to answer. And to do that, it had to go where almost nothing wants to go, into a polar orbit that repeatedly dove close over the cloud tops, skimming past the planet in long, narrow passes, avoiding the worst of the equatorial radiation belts, but never escaping the fact that each encounter was a wager. Every close approach extracted knowledge. Every close approach also spent part of the spacecraft's life. That matters to the emotional shape of this mission. Because Juno was never wandering peacefully through the Jovian system like a tourist with a camera. It was performing repeated acts of controlled exposure. Each pass was a measured descent toward a world that could not be sampled directly and did not yield easily to indirect measurement either. This was not a clean experiment. It was an argument with a planet. And Jupiter almost immediately argued back. The first deep results did not refine the old picture. They began to unmake it. The poles did not look like extensions of the familiar bands. They were crowded with enormous cyclones arranged in strange clustered geometries. The atmosphere was not behaving like a thin, decorative layer wrapped around a settled interior. Ammonia was distributed in patterns that implied deep circulation. The cloud tops were not the boundary they had seemed to be. They were only the place where human vision stopped being useful. That was the first real crack. Not yet the full rupture. Not the deepest blow Juno would deliver to our model of Jupiter, but enough to establish the tone of what was coming. The visible planet was already less honest than it looked. And once that happens, every old comfort becomes unstable. Because if the surface is misleading, then below stops meaning what it used to mean. It no longer promises a clean descent from appearance into reality. It may instead be the place where reality becomes harder to name. That is the threshold Juno crossed. Not just a threshold in space, a threshold in explanation. And beyond it was a planet that did not simply conceal its secrets. It seemed to punish simplification itself. Before gravity could reveal what lay inside Jupiter, before magnetism could expose the structure of its hidden electrical life, before the word core itself began to fail, Juno had to survive the first and most merciless fact about the planet. To learn Jupiter, you first have to endure it. That endurance was engineered into Juno from the beginning. Not as a flourish, as a condition of entry. By the time the spacecraft ever had a chance to tell us what Jupiter was, it first had to survive what Jupiter does. That distinction matters, because it reveals something essential about the planet before a single scientific conclusion is drawn. Jupiter is not merely difficult to understand, it is physically difficult to approach. The obstacle is not just ignorance, it is punishment, radiation, velocity, distance, thermal extremes, communication delay, power scarcity. Before Jupiter becomes an intellectual problem, it becomes an environmental one. Juno was launched in 2011, but arrival was never going to be quick. Nothing about reaching Jupiter is quick. The planet sits so far from the Sun that travel becomes a lesson in patience before it becomes a lesson in science. Juno had to cross billions of kilometers, not in a straight heroic rush, but by the more humbling logic of celestial mechanics. It looped outward, then back inward, then stole momentum from Earth itself in a gravity assist, using one world to reach another. That maneuver always sounds elegant on paper. In reality, it is a confession. Human engineering, for all its precision, still moves through the solar system by bargaining with gravity. And all that time, the spacecraft was flying toward an environment unlike any other planetary destination NASA had attempted to study in such detail. Jupiter's magnetosphere is enormous, so enormous that calling it a magnetic field almost undersells it. It is less like a feature around the planet than a regime imposed on surrounding space. Charged particles from the solar wind, material blasted off Io, electrons and ions accelerated to terrifying energies, all of it gets trapped, whipped, and organized by that field into belts of radiation that can overwhelm ordinary spacecraft electronics. Near Earth, space hardware is already built with radiation in mind. Near Jupiter, radiation becomes one of the central architectural facts. It is not background. It is the atmosphere machines must survive. That is why Juno had a heart of metal. At its center sat a titanium radiation vault, a thick armored chamber enclosing the spacecraft's most vulnerable electronics. Not because titanium is dramatic, because Jupiter makes drama irrelevant. You either shield the nervous system of the machine, or the mission slowly dissolves into noise, corruption, blindness, and failure. The vault could not make Juno invulnerable. Nothing practical could. It could only buy time. That was the philosophy of the entire mission. Not immunity, but resistance. Not safety, but survivability measured orbit by orbit. Even the orbit itself was a kind of negotiated violence. Juno was not placed into a simple low circular path around the planet. That would have been fatal. Instead, it took on a highly elongated polar orbit, one that let the spacecraft dive in close over Jupiter's poles, slash across the cloud tops, gather its data during a brief window of proximity, and then swing far back out again. It was a rhythm of exposure and retreat, a repeated near-drowning. For a short time during each close pass, Juno would skim only a few thousand kilometers above the cloud tops, close enough, in planetary terms, to feel intimate. Then it would flee outward into relative safety, carrying what it had managed to gather. That orbit did more than protect the spacecraft. It changed the entire emotional logic of the mission. Most people imagine planetary exploration as presence, as arrival, as a machine reaching a world and remaining there long enough to calmly inspect it. Juno did not calmly inspect Jupiter. It executed repeated raids. It came in hard and fast, crossing the polar regions where the geometry of Jupiter's magnetic field made the radiation less catastrophic than the equatorial zones. Then used those brief windows to collect the most valuable measurements ever taken of the planet's deep atmosphere, gravity field, and magnetic environment. Each orbit was an argument compressed into hours. Each close approach was a controlled exposure to forces that had no interest in being observed. And because Juno relied on solar power, there was another difficulty braided into all of this that made the mission feel almost improbable from the start. Sunlight at Jupiter is weak, not absent, not dark, but thinned by distance until its character changes. The sun that floods Earth becomes, at Jupiter, something more austere. Light still arrives, but diluted. Its force is spread outward across such enormous space that only a small fraction remains available to do work. That is why Juno had those huge solar arrays, 3 enormous wings extending from the spacecraft, giving it a span wider than a basketball court. Near Earth, solar panels can seem almost routine. Around Jupiter, they look defiant. Vast surfaces built to gather a meager income of light from a star now far away. That choice was risky, and not everyone loved it. For a mission operating so distant from the Sun, nuclear power would have seemed more conventional. But Juno flew on sunlight, and that decision made the spacecraft itself feel like an emissary of precision under constraint, living on a ration of energy while diving through one of the harshest radiation environments in the solar system. So from the beginning, Juno embodied the contradiction that would later define the science. Everything about the mission said Jupiter could not be approached directly, simply, or on human terms. The spacecraft had to be armored because the environment was too violent. It had to orbit carefully because the planet punished prolonged closeness. It had to live on stretched thin sunlight because the journey took it into a region where the sun's generosity had mostly withdrawn. It had to use gravity itself for navigation because directness was too expensive. Even before the data, the form of the mission was already telling the truth about the object it studied. Jupiter was not a place waiting passively to be measured. It was an active problem. And when Juno finally arrived in 2016, that problem became immediate. Orbital insertion around Jupiter was one of those moments where space exploration stops feeling ceremonial and starts feeling exposed. A main engine burn had to occur with almost no room for improvisation, too little deceleration, and Juno would miss the orbit it needed. Too much error, and years of travel could collapse into loss. Signals took too long to travel for real-time rescue. The spacecraft had to perform the maneuver on its own, with Earth listening from far away, helpless except to wait. That is one of the coldest facts in deep space exploration. At the decisive moment, intelligence and intention are separated by silence. Juno made the burn, it entered orbit, and suddenly the largest planet in the solar system was no longer a distant object of telescopes and flyby glimpses. It was something a spacecraft would begin interrogating from within. But even then, the mission did not proceed with the easy rhythm people often imagine after arrival. There were anomalies, concerns about propulsion valves, changes to the original orbital plan. What had once been conceived as a tighter sequence of scientific orbits became something more adaptive, more cautious, more prolonged. In another context that might have seemed like disappointment, around Jupiter, it became part of the character of the mission. The spacecraft survived, it kept working, it kept returning to the planet, and the elongated timing meant Juno spent years turning each close pass into a new incision through the old model of Jupiter. That model had been built from everything we thought we knew before Juno. From telescopes, from theory, from the Pioneer, Voyager, Galileo, and Cassini eras, from spectroscopy and atmospheric dynamics, from assumptions that were reasonable, often elegant, and in many cases partly right. But partly right is dangerous when a planet is this extreme, because a giant world can let an approximation survive for decades simply by being distant enough to protect it. From Earth, Jupiter had always been available first as an image: bands, zones, storms, the Great Red Spot, a rapidly rotating globe of gas wrapped around some hidden interior. Even when scientists were careful, even when the models were sophisticated, the intuition underneath them was still haunted by ordinary habits of thought. A planet has layers, a planet has a center. A magnetic field emerges from some definable region. Weather occupies an atmosphere above a deeper interior. The visible face may be deceptive in detail, but the underlying architecture should still resolve into something more coherent as the measurements improve. That is the belief Juno carried with it into orbit. Not because NASA was naive, because science, like all human reasoning, begins inside forms of intuition before it surpasses them. And Jupiter was about to expose how fragile those intuitions were. The first signs came not from some singular dramatic announcement, but from the subtle humiliation of expectation. Images of the poles showed nothing like the familiar striped planet people thought they knew. Instead, there were clustered cyclones, immense and cold, arranged in strange crowded formations. Instruments probing beneath the visible cloud tops began detecting ammonia, distributed in ways that implied deep plumes and circulation patterns no flat atmospheric picture could comfortably contain. The elegant outer image of Jupiter, bands wrapped around a rotating sphere, was already beginning to peel away. Not because the old image was false, because it was shallow. And that is worse. A false picture can be replaced cleanly, a shallow picture lingers. It remains recognizable enough to seduce the mind even after the deeper structure has started to contradict it. That was the first true service Juno performed for us. Before it resolved Jupiter's hidden machinery, it damaged our confidence in the visible one. The cloud tops were no longer a surface in any satisfying sense. They were a threshold where human eyesight stopped, while the planet itself continued downward into pressure, chemistry, motion, and hidden asymmetry. Once that happens, the question changes. It is no longer, what does Jupiter look like? It becomes, what kind of world has a face this familiar and a depth this unwilling to simplify? To answer that, light was not enough. Juno had to begin listening to invisible things, subtle tugs, buried mass, distortions in motion so small they would have seemed absurd anywhere less consequential. Because the first truly devastating blow to the old Jupiter was not delivered by a camera. It was delivered by gravity. Gravity has one advantage over light. It does not care what a planet wants to show you. Clouds can conceal, colour can mislead, reflection can seduce the eye into thinking it has seen something complete. Gravity does none of that. It reaches outward from the total distribution of mass, indifferent to appearances, indifferent to spectacle, indifferent even to whether the world being measured can be directly seen at all. If light gives you the face of a planet, gravity gives you its insistence. That is why some of Juno's most important measurements looked, from the outside, almost absurdly delicate. The spacecraft was moving at enormous speed through one of the harshest environments in the solar system, and yet part of the scientific strategy depended on detecting minute changes in that motion, tiny deviations in velocity, shifts so slight they would mean nothing to ordinary intuition. But those shifts were everything. As Juno flew over different regions of Jupiter, the uneven distribution of mass inside the planet tugged on it in subtly different ways. Those tugs altered the spacecraft's speed by fractions so small they had to be extracted from radio tracking of extraordinary precision. This is one of the strange beauties of planetary science. Sometimes the deepest interior of a world announces itself not through something violent, but through a whisper in motion. A signal sent from Juno to Earth, then back again. A frequency shift, a tiny compression or stretching in the radio wave caused by the spacecraft moving just a little faster or slower than expected. Buried inside that almost invisible discrepancy was the structure of a planet no human being would ever enter. Juno could not drill into Jupiter. It could not drop through the atmosphere and send back a leisurely cross-section of layers and depths. Jupiter is too deep, too pressurized, too destructive for that fantasy. So instead, the mission did something more elegant. It let the planet reveal itself by the way it pulled. And what Jupiter pulled Juno toward was not the stable picture people were waiting for. Before Juno, there had already been long arguments about what lay inside Jupiter, not because scientists were careless, but because giant planets refuse easy certainty. The traditional image was conceptually simple enough to feel satisfying. Beneath the cloud tops and molecular hydrogen atmosphere, pressure rises, deeper down. Hydrogen enters more exotic states. Somewhere at the center, depending on the model, there might be a compact core made of heavier elements, rock, metals, planetary building material gathered early in the solar system's history and held there under impossible weight. Different versions of the story disagreed in detail, but they still shared a deeper comfort. Jupiter, however strange its weather, would eventually resolve into a structured interior, layers, boundaries, a center that deserved to be called a center. That was the intuition Juno began to erode. At first, not by destroying it outright, but by making it harder to keep clean. The gravity data did not behave the way a neatly compartmentalized planet was supposed to behave. Juno's close passes allowed scientists to map the fine structure of Jupiter's gravitational field with unprecedented accuracy. And the result was not just refinement, it was destabilization. Mass inside Jupiter did not seem distributed in the sharply separated way older, simpler models would have preferred. The deeper readings suggested something more blurred, more mixed, more extended. And this mattered because once mass stops arranging itself in the expected way, the whole mental architecture built on top of that arrangement begins to wobble. Even before the most famous interior result emerged, there was already a quieter revelation hidden in these measurements. Jupiter's atmosphere was not some thin outer skin laid over an inert bulk. The gravitational data, combined with other observations, began to show that the powerful east-west jet streams visible at the cloud tops were not superficial. They extended far downward, thousands of kilometers into the planet. The bands and zones people had admired for centuries were not just meteorological decoration. They were part of a deeper circulation system tied into the body of the world itself. That alone should have been enough to disturb the old picture, because it means the visible surface is not merely a surface. On Earth, weather lives above a solid planet. However deep storms may reach, they still unfold over oceans, mountains, crust, mantle, a world with familiar boundaries beneath them. Jupiter is different. Its great belts, jet streams, and storms are not spread over a solid globe in the ordinary sense. They are expressions of fluid depth. The atmosphere does not sit above the planet as a thin layer distinct from the real body. It is already part of the body. There is no clean moment where weather ends and planet begins. That is one of the first places human intuition starts to fail. We want a threshold, a dividing line, a point where one category gives way to another. Jupiter prefers gradients. The cloud tops fade into deeper atmospheric regions. The atmosphere becomes denser, stranger, hotter, more compressed. Hydrogen changes character, conductivity changes, motion couples to magnetism, and all along the descent, the categories that made the outer image feel understandable start dissolving into one another. Juno was showing that this was not poetic language. It was measurable. When the spacecraft tracked the depth of the zonal winds, it found they plunged much farther than many had expected, roughly to depths on the order of 3,000 kilometers, before giving way to deeper interior behavior. That means the striped face of Jupiter is not a superficial cosmetic pattern. It is a deep dynamic system. Reaching down into a substantial fraction of the outer planet, the familiar image seen from telescopes is only the visible trace of motions with enormous vertical extent. The effect of this discovery is easy to miss if it is phrased too clinically. But imagine what it means physically. What we call a band on Jupiter is not a line painted across a globe. It is the top edge of a moving river in a layer of matter so vast that Earth itself would disappear inside its depth. The colours are only where sunlight happens to stop and scatter. The motion continues long after vision has failed. And once you feel that the planet changes character, it becomes harder to treat Jupiter as a large version of something already known. Harder to imagine it as a globe whose visible atmosphere can be peeled back to reveal a more ordinary interior underneath. The outside is not a wrapper. It is an active expression of hidden depth. That realization prepared the ground for something even more destabilizing, because once Juno had shown that the atmosphere itself was dynamically deep, the old hope of a clean internal structure became more fragile. A planet whose outer motions run this far downward is already telling you that simplicity may not survive contact with measurement. And then there was the ammonia. That detail might sound small compared with gravity and cores and magnetic fields, but it mattered because chemistry can betray circulation in ways images never could. Juno's microwave radiometer was designed to probe beneath the cloud tops by detecting thermal emissions from different depths in the atmosphere. Instead of seeing a relatively uniform distribution that would fit older expectations, the instrument found ammonia arranged in patterns that implied deep transport, upwelling, depletion, and structure extending far below the visible weather layer. In other words, Jupiter was not only deep in motion, it was deep in composition. Materials were being moved vertically through regions hidden from normal sight. The atmosphere was not a flat stack of static layers. It was a restless volume, carrying chemistry downward and upward through pressure regimes where common earthly instincts about weather become almost useless. This is where the mission starts to feel psychologically different. Because early in a story like this, a viewer may still believe the hidden truth will eventually simplify the visible one. Yes, the storms are deeper than expected. Yes, the chemistry is more complex. But perhaps all of this is still just detail on the way toward a stable central answer, a few surprises on the outer way in. Juno did not allow that comfort to last. The deeper it read, the less convincing the old architecture became. And gravity, once it had begun speaking clearly enough, delivered one of the most important blows in planetary science of the last decade. At the center of Jupiter, there seemed to be something like a core, but not a core in the way the word had promised. This is where language itself becomes part of the problem. Core is one of those words that feels scientifically precise, while secretly carrying a heavy burden of intuition. It suggests compactness. It suggests a central object distinct from its surroundings. It suggests a definable region, dense and bounded. However extreme the conditions, even when we imagine immense pressure and exotic states of matter, the word still smuggles in an image of containment, a nucleus, a center that remains itself. Juno's gravity data began to imply something more disturbing. Not the absence of a core exactly. Something worse for intuition. A diluted one, a fuzzy one, a region rich in heavy elements. Yes, but spread out over a vast fraction of the planet's radius, rather than confined to a neat compact center. A central concentration whose boundaries, instead of behaving like a sharp transition, seemed blurred, mixed outward into the surrounding hydrogen and helium envelope. The idea is difficult not because it is technically complicated, though it is, but because it offends the mental picture most people carry without realizing it. It tells you that Jupiter may have formed around a central concentration of heavy material, and yet no longer preserve that material as a clean, isolated interior object. The centre may exist less as a solid thing than as a smeared condition, a deep region where the notion of a sharply separate inner body begins to lose coherence. At the centre of Jupiter, the idea of a centre was failing, and that was not merely a detail about one planet's interior, it was a wound opened in a much larger story. Because giant planets are not just giant objects, they are consequences of formation. Their interiors preserve, however imperfectly, the memory of how matter assembled in the young solar system. A compact heavy core fits comfortably into one family of intuitions about how giant planets grow. First a solid central body accumulates, then gas piles on top, and a clear structural distinction survives in some form. But if that core is diffuse, if the heavy elements are diluted through a vast inner region, then something in that tidy narrative has either been modified, erased, violently disturbed, or was never as tidy as we wanted it to be. This is the point where a planetary measurement becomes philosophical, not because it drifts into vague metaphor, because it reveals how much of science depends, in its early stages, on words that feel firmer than the realities they describe. Surface, layer, interior, core. Jupiter was not rejecting science. It was rejecting premature comfort. And that is why Juno's gravity measurements feel so important even beyond the technical details. They were not simply producing new numbers, they were stripping away an old confidence, the confidence that improved measurement would preserve the same categories while merely refining their values. Sometimes it does. Sometimes better data leaves the architecture standing. And sometimes better data reveals that the architecture was built from approximation all the way down. That was the deeper shift beginning here. Not just that Jupiter had hidden features, not just that it was more complicated than expected. Those are ordinary outcomes in science. The more unsettling outcome is when complication appears in exactly the place where your model needed resolution. The centre was supposed to be where uncertainty narrowed. Instead, it spread. And once that happens, the question can no longer remain local. If Jupiter's core is blurred, then Jupiter's birth may be blurred with it. If its birth is blurred, then the standard story of giant planet formation is no longer something you simply inherit and decorate. It becomes unstable under your feet. Which means the next problem is more dangerous than the first. Juno had not merely complicated Jupiter's present. It was beginning to disturb Jupiter's origin. That is where the real pressure begins. A strange present can be tolerated. A broken origin story is harder. Because once a planet stops matching the form you expected it to preserve, you are no longer just revising a description. You're revising a history. And histories in planetary science are not decorative. They are explanations for why structure exists at all. Jupiter matters so much because it formed early, gathered enormous mass, and likely altered the architecture of the young solar system while that system was still fluid, violent, and unfinished. It is not simply another planet to classify. It is one of the central events of solar system formation still sitting in front of us. If Jupiter's interior is not organized the way we thought, then some part of the story of how worlds grow large enough to dominate their surroundings has to be reopened. For a long time, the most persuasive broad picture was elegant in the way successful scientific stories often are. A giant planet begins with a core of heavy material, rock, ice, metals, condensed solids gathering from the disk around the young sun. That core grows until its gravity becomes strong enough to pull in vast amounts of gas. Hydrogen and helium flood inward. The planet swells, a giant is born. Different models varied in timescale, composition, and details of the surrounding disk. But the basic intuition held together because it felt structurally right. First a seed, then growth. First heaviness gathered inward, then gas piled above it. It made sense of Jupiter. It made sense of Saturn. It helped explain why the giant planets exist at all. And most of all, it preserved an idea that human intuition finds deeply comforting, that early causes remain legible inside later structure. Build a world around a core, and somewhere in that world the core should still be there, distinct enough to deserve the name. But Juno was now suggesting a deeper possibility. What if Jupiter did form around such a core, and the evidence of that beginning no longer survives in a compact, cleanly bounded form? What if the centre was not absent, but diluted, mixed outward into a deep region where heavy material and surrounding fluid no longer keep the boundary our language expects? That possibility is scientifically rich, but emotionally it feels like a betrayal, because it means formation may not leave behind the neat fossil we were hoping to find. A planet can remember its birth without preserving it in a shape the mind likes. There are several ways this could happen, and none of them restore the old comfort. One possibility is that Jupiter's core, if it began compact, partially dissolved into the surrounding layers over immense time, under the pressures and temperatures deep inside a giant planet. Matter does not behave in the civilized way it behaves near the surface of Earth. Materials can become soluble in environments where ordinary categories of solid, liquid, and gas are already under strain. Heavy elements need not remain locked forever in a sharply separate object if the surrounding conditions allow them to spread, mix, and diffuse. Another possibility is more violent. In the early solar system, worlds were not assembling in tranquility. Orbits shifted, massive bodies migrated, collisions were not rare interruptions to order. They were part of how order was made. Some researchers have explored the idea that Jupiter may have suffered a gigantic impact after its initial formation, an impact energetic enough to disrupt, stir, and dilute the inner structure, smearing what might once have been a more compact core into a broader fuzzy region. That idea has an almost mythic brutality to it, but its real significance is more precise. It reminds us that interior structure is not just the outcome of peaceful accumulation. It can also be the scar of later violence. And once you admit that, giant planets start to feel less like static categories and more like dynamic biographies written in pressure and disruption. The reason this matters so much is that Jupiter is not alone. Saturn, too, has shown signs that its inner structure may not fit the old simple picture. Independent lines of research have pointed toward the possibility of an extended, diffuse inner region there as well, a kind of diluted core spread over a substantial fraction of the planet rather than locked into a compact central body. That does not automatically mean Jupiter and Saturn share the same history in every detail, but it does something perhaps more important. It weakens the hope that Jupiter is a one-off anomaly. If both of the solar system's great gas giants blur the boundary we expected to find, then maybe the boundary itself was always less fundamental than we assumed. That is a dangerous thought for a clean model, because the old intuition was never just about cores, it was about organization. We like to believe that as planets become larger and more massive, their internal logic becomes more definitive, more pressure, more compression, more gravity. Surely that should force structure into cleaner forms. But giant planets may do something less comforting. They may preserve early history and later disruption at the same time, locking both into a state that is lawful, measurable, and still resistant to simple classification. In that sense, a fuzzy core is not merely a technical refinement. It is a philosophical insult to boundary thinking. It tells you that even at colossal scale, nature may prefer transition over separation. And yet the deeper one goes into the physics, the more disciplined this strangeness becomes. This is not mystery in place of mechanism. It is mechanism creating a result that feels stranger than our simpler stories could tolerate. Deep inside Jupiter, pressure climbs to millions of times the atmospheric pressure at Earth's surface. Temperature rises into ranges where familiar material behavior becomes almost unusable as a guide. Hydrogen, the lightest element, becomes metallic under extreme compression, no longer behaving like the neutral gas of balloons and nebulae, but like an electrically conducting fluid. Helium interacts with it under conditions difficult to reproduce in laboratories for more than fleeting moments. Heavy elements are embedded in that environment, and the question is not simply whether a core exists, but how materials move, mix, separate, dissolve, and remain suspended across immense spans of time. That phrase matters, across immense spans of time, because Jupiter is old, not old by human standards, old in the severe planetary sense. It has existed for more than 4 billion years. Any interior process that can act slowly, persistently, and at scale has had time to matter. Diffusion matters, convection matters, phase transitions matter, double diffusive layering may matter, gradual exchange between regions matters. The giant planet you measure today is not only the result of formation, it is the result of everything formation set in motion, and everything deep time refused to leave untouched. So the temptation to ask whether Jupiter has a core begins to look almost childish, not because the question is foolish, but because the answer may no longer fit inside the grammar of yes or no. That is one of the most important changes Juno forces on the imagination. Science often begins by asking clean questions because clean questions are how a mind gets leverage on a complicated world. But reality is under no obligation to return clean answers in the same form. Sometimes the mature version of a question becomes harder, longer, less satisfying, and more truthful. Not, does Jupiter have a core? But, in what sense can a giant planet preserve a central concentration of heavy material after billions of years of compression, mixing, and possible disruption, and what kind of boundary, if any, survives between that region and the rest of the interior? That is a colder question. A better one, and it widens the stakes beyond Jupiter itself, because giant planets are not rare curiosities anymore. Once exoplanet discoveries began accumulating, it became clear that worlds of enormous mass, thick atmospheres, intense irradiation, and unfamiliar interior states are common features of the galaxy. Hot Jupiters, warm Jupiters, super Jovian worlds, inflated giants. Our solar system is not the only laboratory in which massive gaseous planets exist. If our conceptual language for Jupiter and Saturn is crude, then our language for giant planets in general may also be cruder than we admit. Which means Juno is doing something larger than solving a local puzzle. It is testing whether one of our most basic planetary categories was ever too clean for the reality it tried to describe. And the answer seems to be yes. But this is where the story becomes even more unsettling, because a diluted core could still have been absorbed into a larger, more stable picture if the rest of Jupiter's hidden structure had behaved beautifully. If gravity had said, yes, the center is blurred, but elsewhere the architecture is elegant. If magnetism had traced a symmetrical dynamo, if deep flows had resolved into a model whose cleanliness compensated for the loss of the old core, that is not what happened. The deeper model did not restore simplicity. It widened the failure of it. Jupiter was not only refusing to preserve a compact central core, it was also generating a magnetic field more irregular than expected, with striking regional intensity, asymmetry between hemispheres, and signs of temporal change. The old comforting image of a giant planet with a large, orderly internal dynamo, something immense but conceptually manageable, began to look less secure. This matters because magnetic fields are among the most intimate external expressions of a planet's hidden interior. You cannot see the conducting fluid directly, but you can watch what its motion writes into surrounding space. If gravity gave Juno the distribution of mass, magnetism offered something more alive, a record of deep electrical motion still happening now. And Jupiter's magnetic field was not writing a calm sentence. It was writing something jagged. At first glance, that may not sound as emotionally destabilizing as the fuzzy core, but in some ways it is worse, because a strange magnetic field means the hidden interior is not merely a historical puzzle. It is an active, ongoing generator of asymmetry. The planet is not just preserving ancient ambiguity. It is continually expressing internal structure in ways that challenge simplified models. That is the midpoint where many science stories would offer relief. The first mystery is solved, a deeper mechanism is introduced, and the narrative tightens back into order. Jupiter refuses that rhythm. Every time Juno pushed farther under the visible image, the reward was not closure. It was a more demanding planet. A world whose center was less bounded, whose weather was deeper than appearance allowed, whose formation story was under revision, and whose invisible electrical life was beginning to look oddly lopsided. The breakthrough was real. So was the new ignorance. And that is where the descent changes character, because now the question is no longer just what lies below Jupiter's clouds. It is what kind of world produces a magnetic field like this at all. A magnetic field sounds abstract until you remember what it really is. It is movement made visible by consequence. Somewhere inside a planet, electrically conductive material is in motion, circulating, shearing, rising, sinking, rotating through conditions extreme enough to turn fluid dynamics into planetary architecture. That motion generates a magnetic field, and the field escapes the body that made it, spreading outward into space where instruments can map it, particles can follow it, and auroras can flare along its lines like exposed nerves. A magnetic field is invisible, yes, but it is not intangible. It is one of the few ways an interior can keep speaking outside itself. That is why Juno's measurements mattered so much. Because before the mission, scientists already knew Jupiter's magnetic field was immense. Even from afar, it was obvious that this was not some minor planetary accessory. Jupiter's field is the strongest of any planet in the solar system by a huge margin. It traps radiation, shapes enormous belts of charged particles, couples to the solar wind, and extends so far into space that the region it dominates becomes less like an envelope and more like a kingdom. But strong is only the first layer of meaning. Strength alone does not tell you how the interior works. A field can be powerful and still be relatively orderly. A field can be large and still preserve a symmetry that makes the deep mechanism feel at least conceptually manageable. Juno found something less comforting. The field was not just strong. It was oddly shaped, intensely uneven, and in places far more localized than many expected. This is where the imagination needs recalibrating. When most people hear that a planet has a magnetic field, they unconsciously picture something simple, something like a bar magnet, perhaps tilted, perhaps imperfect, but broadly dipolar, with a north, a south, and a field geometry that remains legible at large scale. Even when the real physics is more complex, that image lingers. It offers the mind a way to compress the phenomenon into something clean. Jupiter again refused the compression. Juno's magnetometer mapped the field with extraordinary precision during repeated close passes over different latitudes and longitudes, and what emerged was not a tidy global pattern with minor deviations. It was a field marked by dramatic asymmetry. In some regions, the intensity surged far above surrounding areas. In others, the structure bent away from what a simple dynamo picture would lead you to expect. The northern hemisphere, in particular, revealed a magnetic complexity that did not mirror the south in any comforting way. One feature became especially famous, a region informally known as the Great Blue Spot. The name can sound almost playful, which is unfortunate, because what it signifies is profound. This was not a little blemish on an otherwise orderly planetary field. It was a vast area of concentrated magnetic intensity near the equator, a place where Jupiter's field strength was strikingly stronger than a simple model would predict. Not a decorative irregularity, a clue. A wound in the assumption that the deep generator beneath the field was broadly symmetrical and easy to smooth out mathematically. You can feel the danger of that clue immediately. If a magnetic field is the outward signature of electrical motion in the interior, then a field this uneven implies that the motion generating it is also uneven, or at least that the conducting regions, flow structures, and transitions that sustain the dynamo are distributed in ways more complicated than the old mental picture allowed. That turns magnetism into a form of confession. Jupiter's gravity had already suggested that the planet's mass was not organized into a sharply bounded, intuitively satisfying interior. Now its magnetic field was suggesting that the active electrical life of that interior was not organized in a simple global symmetry either. The hidden world was not just blurred, it was dynamically lopsided. And because Juno returned again and again, the mission could do something even more revealing. It could watch for change. That matters because a magnetic field is not a fossil in the same sense as interior mass distribution. It is being generated now. It is alive to present motion. If the field shifts over time, even subtly, then the hidden flows that sustain it are themselves evolving in measurable ways. Juno detected signs of what is called secular variation, changes in Jupiter's magnetic field over the years of the mission. Not wild chaos, not some collapse of physical law, but enough to show that the planet's deep electrical machinery is not frozen into a static pattern. It is moving, adjusting, rewriting its own invisible structure in real time. That is one of the coldest realizations Juno offered. The interior of Jupiter is not merely difficult to reconstruct as history. It is actively happening. And to understand why that matters, you have to go deeper into the physical engine of the field itself. Somewhere beneath the outer layers of molecular hydrogen, Jupiter's interior enters a regime of such crushing pressure that hydrogen changes character. It becomes metallic, not a metal in the ordinary everyday sense of a solid bar or sheet, but a dense, electrically conductive fluid. This is one of the great alien transitions in planetary physics, the most abundant element in the universe, which near Earth behaves like a light transparent gas, is forced under Jovian pressure into a state where electrons move freely enough for the material to conduct electricity on a colossal scale. Once that happens, motion through the fluid can generate a dynamo. That much was expected, but where exactly that conductive region begins, how sharply it transitions from the outer layers, how composition changes with depth, how helium and heavier elements influence conductivity and convection, how rapidly different zones rotate, how deep the zonal flows penetrate before the magnetic environment begins to alter them. Those are not small details. They determine the character of the dynamo itself, and Juno's field map suggested that character was not simple. One possibility is that the magnetic field is being generated relatively closer to the outer layers than older models emphasized, in a region where the transition to metallic hydrogen and the overlying dynamics produce more intricate patterns than a deeper, smoother dynamo would. Another is that compositional gradients and layered convection inside Jupiter constrain fluid motion into structures capable of producing the observed asymmetries. Still another is that the coupling between deep flow and field generation is more sensitive to boundary conditions than our simpler theories preferred. The technical debates matter, but their shared message matters more. Jupiter's field is telling us that the interior is not just vast. It is structured in a way that does not average out cleanly. That phrase, does not average out cleanly, captures something essential about why this discovery feels so unsettling. Many scientific models survive complexity by letting local irregularities disappear into large-scale order. Small deviations cancel. Noise smooths away. The deeper pattern remains elegant. Jupiter has a way of preserving local difference at scales too large to call local in any ordinary sense. It lets asymmetry survive magnificently, and the emotional result is unusual. The deeper mechanism does not make the planet feel more mechanical in the reductive sense. It makes it feel more alive without being alive. Not animate, not conscious, but active in the severe way giant systems can be active, continually generating structure, continually externalizing inner conditions through invisible architecture that extends millions of kilometers beyond the body itself. This is where the word field stops sounding bloodless. Imagine space around Jupiter not as emptiness with a planet placed inside it, but as a domain continuously rewritten by currents from within the planet, charged particles spiraling along magnetic lines, radiation belts swollen and sustained by the field, auroras igniting at the poles where particles plunge into the atmosphere, invisible geometries tying the deep interior to high-latitude light. The magnetic field is not a halo. It is the outward behavior of the interior spread into space. And because Jupiter rotates so quickly, once in roughly 10 hours, the whole system is under relentless dynamical pressure. Rapid rotation organizes flow. Coriolis forces become severe. Conductive fluids move within a geometry dominated by speed, depth, and immense scale. The result is not just a magnetic field, but an entire magnetospheric regime, fed by the planet's spin, by the solar wind, by material from moons like Io, and by the strange internal arrangements Juno has only begun to expose. That last point matters because Jupiter's moons are not separate from this story. Not yet in the foreground, but already in the circuitry, Io, in particular, erupts material into space that becomes ionized and trapped within Jupiter's magnetic influence. The planet is not generating its field in isolation from its system. It is embedded in feedbacks, exchanges, and particle environments that widen the meaning of what Jupiter even is. But before those outer consequences fully come into view, the interior itself has already forced the deeper lesson. The old hope had been that hidden structure would produce hidden elegance. Instead, the hidden structure produced a symmetry that remained legible even at planetary scale. This is one of the reasons Juno feels less like a mission that merely added information and more like one that altered tone. Before Juno, it was possible to imagine Jupiter as a giant but essentially classical object, layered, rotating, convecting, magnetized, perhaps exotic in detail but still obedient to a fairly clean internal hierarchy. After Juno, Jupiter feels harsher, not lawless, but less willing to collapse into one grand simplified picture. The laws are there. The challenge is that they are expressing themselves through a world whose transitions, gradients, and active structures do not honour the neat boundaries we were hoping for. And once that becomes clear, magnetism stops being just one more discovery on the list. It becomes a second blow against the same illusion. The first blow came from gravity. The centre was not compact in the way intuition wanted. The second came from the field. The active interior was not globally smooth in the way intuition wanted either. Different instruments, same humiliation. That is the deeper pattern in this story. Juno was not finding unrelated curiosities. It was discovering, again and again, that Jupiter punishes the human hunger for simple hidden architecture. Every method that reached below the visible clouds returned some version of the same answer. Deeper reality was real, measurable, lawful, and less psychologically accommodating than expected. And once you understand that, the planet's storms start to change meaning too. Because if the interior is this dynamically strange, then the weather above it cannot remain just weather. Those belts, vortices, and famous storms at the cloud tops are no longer superficial theatre. They begin to look like surface expressions of a much deeper continuity, a continuity between atmosphere and body, between visible turbulence and buried structure, which means the next step down is not into another separate category. It is into the realization that on Jupiter, weather is part of the planet's anatomy. That is where Jupiter becomes harder to describe in any familiar language. On Earth, weather is dramatic but secondary. However violent a storm may feel from inside it, we still experience it as something happening above the planet, not as the planet itself. Hurricanes do not define Earth's internal structure. Jet streams do not reach down into the mantle. Thunderheads do not force us to reconsider what a core is. Weather, for us, is surface behaviour, intense, consequential, even deadly, but still surface behaviour. Jupiter erases that comfort. Its storms are not painted onto a stable globe. They are not a decorative skin wrapped around a settled interior. They are part of a fluid continuum extending downward into regions of pressure, composition, and motion so immense that the ordinary word atmosphere begins to feel too thin. The visible weather of Jupiter is not sitting on the planet. It is already inside it. That shift matters because it transforms what we are looking at when we look at the famous face of Jupiter, the coloured bands, the pale zones, the darker belts, the whirls, the oval storms, the great red vortex that has survived human history. None of these are merely meteorological artwork spread across a spherical canvas. They are the upper trace of dynamics descending far below the cloud tops. What seems like pattern is depth made partially visible. What seems like weather is structure announcing itself in colour and motion. Juno helped prove this with a precision no previous mission could match. The spacecraft's gravity measurements, combined with the rest of its atmospheric probing, showed that Jupiter's zonal winds, the powerful east-west flows responsible for its banded appearance, are not confined to a shallow shell. They extend downward thousands of kilometres. That discovery had a strange emotional effect. It did not make the planet feel more dramatic in the easy cinematic sense. It made it feel less separable. The boundary the mind wants to place between outer appearance and inner reality began to dissolve. Think about what that means physically. A band on Jupiter can span the entire planet, wrap around a circumference of hundreds of thousands of kilometres, and still represent only the upper visible edge of a moving system plunging downward to depths that would swallow Earth whole. The cloud tops are not a finished image. They are a cut surface through a process still continuing beneath sight. That is why the Great Red Spot, for all its fame, became newly interesting under Juno, not because it was simply large, but because it could no longer be treated as a surface stain. For centuries, it had lived in the imagination as a giant storm, which is true, but incomplete in the way a map can be true and still fail to prepare you for the terrain. Juno's microwave observations and gravitational constraints helped show that this was not just a broad atmospheric swirl lingering in thin outer layers. The storm descended, not indefinitely, not all the way into the deep interior, but far enough to break any ordinary sense of weather as something skin-deep. The Great Red Spot appears, from above, like a wound that never closes. From within the physics, it is worse than that. It is a long-lived vortex embedded in a planetary fluid system whose vertical extent and energetic persistence force a more serious question. What sort of world allows weather to acquire this much depth, this much inertia, this much historical duration? Because storms on Earth are transient in a way that feels emotionally normal to us. They build, intensify, scatter, dissipate. Their mortality is part of how we understand them. Even the largest hurricanes belong to a cycle we can recognize. Jupiter's great vortices do not honor that same rhythm. They can persist for years, decades, centuries. They drift, they shrink, they interact, they alter in color and size. But they also endure in a world where endurance itself is being driven by a fluid architecture of astonishing scale. That is one of Jupiter's most unsettling habits. It takes a familiar category and stretches it until the familiarity becomes deceptive. Storm, atmosphere, wind, cloud. The words remain usable. The intuitions behind them do not. And the farther Juno pushed into the planet's weather systems, the clearer that became. Its microwave radiometer could probe below the visible cloud deck by detecting thermal emissions from different depths, effectively allowing scientists to infer the distribution of certain compounds far beneath where cameras see reflected sunlight. This mattered because visible imagery alone is treacherous on a world like Jupiter. Colors can suggest structure that chemistry denies. Shapes can imply flatness where depth is immense. A storm that looks self-contained may belong to a circulation pattern extending far beyond what light reveals. The microwave data showed just how deceptive the outer image could be. At different depths, Jupiter did not simply preserve a tidy vertical stack of gases. It showed variation, plumes, depleted regions, enriched regions, complex circulation in ammonia and other constituents, evidence that material was being moved through the planet in ways the eye could never have reconstructed. The atmosphere was not a calm, layered archive. It was a conveyor of chemistry through pressure regimes alien to common weather intuition. And once again, the most important effect of this was not that Jupiter grew more complicated. Complexity by itself is almost expected in modern science. The deeper effect was that different kinds of measurement kept agreeing on the same philosophical insult. The visible world was not the fundamental one. Gravity had said the interior mass distribution was less bounded than expected. Magnetism had said the electrical life of the deep planet was asymmetrical and active. Now atmospheric probing was saying the visible weather was not superficial decoration, but a shallow glimpse of deeper motion and transport. Different methods and same humiliation. The cloud tops were not lying exactly. They were simply not enough. That makes Jupiter feel less like an object and more like a threshold. A place where categories inherited from terrestrial experience remain useful only so long as you do not trust them too much. If you insist on treating Jupiter as a giant version of something you already understand, the planet lets you keep that illusion just long enough to embarrass it. The embarrassment deepens near the poles. From Earth, and even from many earlier spacecraft perspectives, Jupiter's iconic identity was its banding, the planet as a horizontally striped giant, orderly in its broad appearance even when turbulent in detail. Juno changed that by repeatedly diving over the poles, regions no previous mission had seen with such sustained intimacy. And what appeared there did not feel like a natural extension of the familiar image. It felt like another planet hidden at the ends of the same one. The poles were crowded with cyclones. Not a few scattered storms, not loose irregular turbulence, great clustered vortices, arranged in persistent geometries, multiple giant storms packed around a central one, like fluid architecture trying to stabilize itself at the edge of chaos. The north and south were not identical, which only deepened the strangeness. They were not random either. These systems displayed a kind of order, but not the clean order of a textbook diagram. A harsher one, a negotiated order, storms pressing against one another, maintaining distance, organizing into patterns that felt less meteorological than almost orbital. It is difficult to overstate how psychologically important those images were, because they broke the last easy visual shorthand people had for Jupiter. The banded giant was real, but incomplete. The familiar planet was real, but provincial. At the poles, Jupiter stopped looking like an icon and started looking like a fluid intelligence built by physics alone. That does not mean the storms are mystical. They are not. Their behavior arises from rotation, convection, stratification, pressure gradients, vorticity, and the severe dynamical environment of a rapidly spinning giant planet. But good science does not become less haunting when it is explained. Sometimes it becomes more haunting because the explanation reveals a deeper indifference. No intention, no symbolism, just law producing a result far stranger than the old image deserved. And law, on Jupiter, often works through depth. That is the point worth holding on to here. The storms are not interesting because they are colourful. They are interesting because they reveal continuity between what we can see and what we cannot. They are evidence that the cloud tops are not a boundary but a leak, a place where a little of the planet's hidden structure becomes briefly legible in form, colour, and turbulence. This is why the phrase "beneath Jupiter's clouds" becomes so slippery. It sounds as if the mission was travelling from one layer to another, first the visible top, then the hidden world below. But Juno kept finding that the hidden world was already expressing itself through the visible one. The descent was real, but not clean. Below did not mean separate, it meant deeper inside a connected system. And that makes the next discovery feel almost inevitable. Because once weather is no longer just weather, the chemistry inside that weather becomes more than chemistry too. Water, lightning, ammonia, pressure, freezing, convective transport. On Earth these can still be folded back into a recognizably atmospheric story. On Jupiter they begin to behave like ingredients in a planetary process whose logic is familiar only in fragments. The storms were already telling us that Jupiter's weather had depth. What came next was the realization that even its rain does not fall the way intuition wants it to. Because on Jupiter, even a thunderstorm is no longer allowed to remain ordinary. There are certain patterns the mind carries so deeply it mistakes them for reality itself. Warm air rises, water condenses, ice forms at altitude, rain falls downward. Lightning belongs to turbulent clouds where charges separate through collisions between droplets, crystals, and ice. These are not childish intuitions. They are disciplined by life on Earth. They work well enough, often beautifully, inside the atmosphere we know. Then Jupiter takes those same ingredients, water, ammonia, convection, ice, electricity, and rearranges the conditions so completely that the old pattern survives only as a ghost. This is where the planet becomes physically vivid in a way that is difficult to forget. Deep in Jupiter's atmosphere, water is not absent. It matters enormously, but it is hidden under pressures and temperatures far beyond the level where sunlight reveals clean visual clues. To understand where it is, how much of it there is, and what role it plays in storm formation, Juno had to probe downward using microwave measurements, reading emissions from beneath the cloud tops the way a physician might read an organ through a body no scalpel could safely open. That was crucial because water on Jupiter is not just a chemical detail. It is part of the thermal engine of the atmosphere, part of the convective violence that drives towering storms and the separation of charge that leads to lightning. And yet even here, the familiar story immediately starts mutating. Juno detected lightning in places higher in the atmosphere than many researchers had expected, regions so cold that pure water should have been frozen out in a way that makes ordinary terrestrial lightning generation hard to explain. On Earth, lightning usually forms in deep storm systems where water and ice interact under conditions that allow electric charge to separate efficiently. The ingredients are specific, the altitude range is not arbitrary, but on Jupiter, flashes were appearing where the simple Earth-based analogy began to break. That mattered because it meant the chemistry of Jovian storms was doing something more inventive. The best explanation involves ammonia. Ammonia is one of those substances that, on Earth, lives more often in chemistry than in weather imagination. On Jupiter it becomes meteorological destiny. When ammonia mixes with water, it can lower the freezing point of the mixture, allowing liquid or slushy phases to exist higher and colder than pure water alone would permit. In effect, ammonia changes the atmospheric script. It allows storms in frigid upper regions to host forms of liquid interaction that would otherwise be difficult, making charge separation, and therefore lightning, possible at altitudes where the old intuition expected silence. That is an important kind of strangeness. Not magic, not exception. Just chemistry behaving lawfully in a world whose conditions are alien enough to make the lawful result feel wrong. And once scientists started following that logic, the atmosphere grew stranger still. There is now strong evidence that some Jovian storms produce what researchers informally call mushballs, soft hail-like clumps made of ammonia water slush. Mixed perhaps with ice, forming high and powerful convective towers before falling deeper into the atmosphere. The name sounds almost unserious, but the process it describes is profound. In these storms, water and ammonia can be lofted high upward, interact in cold regions, form slushy conglomerates, then descend, dragging chemical material downward in a way that helps explain why ammonia can appear depleted in some upper layers and redistributed at depth. This is not just exotic weather. It is atmospheric transport operating through alien precipitation. On Earth, hail already feels like weather carrying geology inside it, hard stones of sky, briefly impossible in the hand. On Jupiter, the equivalent is stranger, soft, chemically mixed pellets forming in convective violence within a hydrogen-helium atmosphere under pressures and temperatures that make every step of the familiar Earth analogy slightly false. These objects may fall through tremendous vertical distances, carrying volatiles downward into deeper regions where they vanish from the layers our instruments most easily sample. That helps solve one of the puzzles Juno confronted: the uneven distribution of ammonia in Jupiter's atmosphere. If giant storms are manufacturing these ammonia water mushballs and hurling material upward before it falls back down, then Jupiter is not only circulating gas, it is actively sorting chemistry through convective events that blur the boundary between weather and deep composition. The cloud tops, once again, are just the visible edge of a much deeper process. And lightning, once again, is not merely spectacle, it is evidence. That is one of the quiet triumphs of Juno. It kept taking phenomena that seemed visually dramatic, storms, auroras, lightning, bands, and making them scientifically severe. It took what looked like surface theatre and turned it into a set of diagnostics for hidden structure. Every flash, every asymmetry, every vertical chemical anomaly became part of a deeper sentence Jupiter was writing about itself. The trouble was that the sentence never simplified. Water is another example of that. For decades, scientists have wanted to know how much water Jupiter actually contains, because that question touches everything from planetary formation to atmospheric circulation. Water abundance can constrain models of how the planet formed and what material was available in the young solar system. But measuring water on Jupiter is difficult precisely because the planet refuses to expose it where we would most like to see it. Much of the relevant water lies too deep beneath the visible cloud tops for easy detection from ordinary observation. Earlier efforts, including the Galileo probe that entered Jupiter's atmosphere in the 1990s, produced results that were valuable but also frustratingly local, possibly sampling an unusually dry region rather than a globally representative one. Juno improved the situation by probing near the equator with microwave instruments sensitive to deep atmospheric water. The result was not a final, perfectly closed answer for the entire planet, but it was a major step toward a truer one. Jupiter's atmosphere appears to hold more water than Galileo's local entry point had suggested, enough to reshape how scientists think about the planet's composition and convective behavior. Yet even here, where a mission might have offered closure, Jupiter withheld completeness. The equator may not represent every latitude. Distribution matters, depth matters, dynamics matter. The planet gives you a better answer, then reminds you that better is not the same as simple. This is the midpoint truth Juno kept enforcing. A breakthrough is not the same thing as a reduction. Sometimes it is the opposite. Sometimes a breakthrough enlarges the amount of reality you now have to hold at once. That is exactly what happened here. Water was not just present or absent. Ammonia was not just a trace constituent. Storms were not just convective towers. Lightning was not just visual punctuation. All of them were entangled in a deeper process of vertical transport, chemical mixing, thermal structure, and atmospheric depth. Each measurement clarified one mechanism while also widening the system it had to belong to. The weather was becoming planetary in a more literal sense. And this has a physical force the viewer should be allowed to feel. Imagine a Jovian storm tower rising through the atmosphere not over kilometers in the human sense, but through vertical domains so vast that terrestrial comparison starts to fail. Material is being lifted upward through powerful convection, entering colder layers where ammonia changes the freezing behavior of water, forming slush-like hail that then falls back down through darker, denser regions, carrying chemistry with it. Above that, lightning flashes in blue-white silence. Below it, Pressure builds into regimes where the atmosphere no longer feels like air at all, only a thickening planetary fluid. Around it, the banded winds continue their immense horizontal motion, while deeper down the whole system is tied into the giant rotating body of the planet. That is not weather over a world. That is a world behaving as weather. And this is where the script's central illusion breaks more completely than before. The old hope was that if we could get beneath Jupiter's clouds, we would find the planet underneath them. But Juno kept discovering that the clouds are not covering the real world below. They are one visible expression of it. The atmosphere is not a curtain in front of the planet. It is part of the planet's body, part of its memory, part of the way hidden structure leaks upward into sight. This is also why the visual image of Jupiter becomes more deceptive the better you know it. From afar, the banding looks organized. Up close, the storms look dramatic. Scientifically, the whole visible face becomes suspect, not because it is false, but because it is too shallow to tell the truth by itself. That distinction is crucial. The mission did not teach us to distrust appearances in the cheap sense. It taught us something harsher. Appearances can be accurate and still radically incomplete. The stripes are real, the storms are real, the colours are real. But the meaning of those things changes once you know how deep they go, how strange their chemistry is, how entangled they are with hidden flows and transitions far below the cloud tops. Jupiter is one of the best examples in the solar system of a world whose image is famous, and whose reality is still not emotionally assimilated. We know what it looks like. We do not naturally know what it is. And the more Juno revealed, the less those two kinds of knowing were allowed to remain close together. The consequences do not stop with storms. In fact, storms are only one place where Jupiter's interior writes itself outward. Another is at the poles, where the planet's magnetic field, atmosphere, rotation, and incoming charged particles combine to produce phenomena so large and so energetic that even the word aurora starts to feel insufficient. On Earth, auroras are beautiful because they seem delicate. On Jupiter, they are beautiful because they are severe. And they make one final point impossible to ignore. The hidden structure of the planet does not end at the cloud tops, or even at the top of the atmosphere. It extends into space itself, where Jupiter's interior continues speaking in light. And in that light, Jupiter stops looking like a planet surrounded by space. It starts looking like a planet that has imposed itself on space. That is what an aurora really reveals at Jupiter. Not just beauty, not just charged particles striking an atmosphere. It reveals scale translated into consequence. The deep interior generates a magnetic field. The field shapes the motion of particles. The particles fall along those invisible lines into the polar atmosphere. Energy is released. Light blooms. But unlike Earth's auroras, which already feel extraordinary to us, Jupiter's are larger, more powerful, more persistent, and in some wavelengths almost brutally intense. They are not fleeting curtains at the edge of a quiet sky. They are part of a planetary electrical system so immense that the visible glow is only the local wound where a much larger invisible structure touches gas. This matters because auroras can seem decorative if described lazily. A nice visual, a cosmic flourish. On Jupiter, they are nothing of the kind. They are one of the clearest signs that the planet's hidden life extends far beyond anything a camera sees when it points at the cloud tops. The auroras are where interior physics, magnetospheric structure, atmospheric chemistry, solar-wind interaction, and the contribution of the moons all converge into something the eye can finally register. In other words, they are not an effect added to Jupiter. They are Jupiter continuing outward. Juno saw them from above the poles, in geometries no earlier mission had observed with the same repeated intimacy. That vantage point was crucial. Earth-based telescopes and previous spacecraft had already shown that Jupiter's auroras were spectacular, but Juno turned them from spectacle into anatomy. It flew through the regions where the relevant particles moved. It measured the field. It tracked the emissions. It watched how the planet's rotation, plasma environment, and magnetospheric currents coupled to the upper atmosphere. And the result was not a single neat auroral story, but another layer of the same lesson Juno kept teaching everywhere else. Jupiter's visible expressions are real, lawful, and far less simple than the human mind wants them to be. On Earth, auroras are strongly tied to the solar wind. The sun throws charged particles outward. Earth's magnetic field guides some of them, and the polar atmosphere glows when those particles dump energy into it. That story is not wrong for Jupiter, but it is incomplete in a way that matters. Jupiter's auroral system is not just a passive response to what the Sun delivers. The planet helps power its own severity, its rapid rotation, immense magnetic field, and internal plasma dynamics create an auroral regime with an energy budget and structure that cannot be reduced to solar weather alone. And then there is Io. Even before Io takes center stage as one of the most violent moons in the solar system, it is already present here as a kind of electrical accomplice. Volcanic material blasted from Io becomes ionized and trapped within Jupiter's magnetosphere, feeding a torus of charged particles and participating in current systems that connect moon and planet. This means Jupiter's auroras are not merely a conversation between the planet and the Sun. They are part of a wider circuit involving the moons, the magnetic field, the plasma environment, and the rotating body of Jupiter itself. The system is recursive. The planet shapes the space around it. The space around it carries charged matter. That matter comes partly from a moon Jupiter is torturing gravitationally. The resulting currents and particles fall back into the atmosphere. The atmosphere glows, and what glows is a trace of internal structure written across the poles. This is why the auroras matter narratively. They are the place where all the hidden architecture we have been descending through suddenly becomes visible again, but at a different scale. Gravity exposed the blurred organization of mass. Magnetism exposed the asymmetry of the active interior. Storms exposed the continuity between weather and body. Auroras now expose the continuity between body and surrounding space. The old image of a planet as a self-contained object is becoming harder to defend. Jupiter is not a sphere with features. It is a system of gradients, fields, flows, and exchanges whose visible body is only one part of the whole. That recognition changes the emotional temperature of the story. Until now, much of the tension has come from depth, what lies below the clouds, below the visible atmosphere, below the words we thought were stable. The auroras invert that direction. Suddenly the consequence is above, outside, and far beyond. The hidden interior is not merely buried, it is expansive. It reaches outward through magnetic structure and particle motion into a domain so large that around the planet becomes a misleading phrase. Jupiter's magnetosphere extends millions of kilometers into space. It bulges, flexes, trails, reconnects, and resists the solar wind on a scale almost difficult to mentally hold. The auroras are just the bright points where that invisible empire touches the atmosphere, and Juno, repeatedly, passed through the edges of that empire. There is something severe about the image if you let it settle. A human-built machine, solar-powered in the weak light 5 times farther from the Sun than Earth, diving over the poles of the largest planet in the solar system, moving through radiation and magnetic complexity, while below it the atmosphere glows where charged particles strike. And beneath that glow lies a world whose center is blurred, whose storms descend into hidden depths, whose chemistry behaves in alien ways, whose field is asymmetrical, whose whole planetary character becomes less settled the more precisely it is measured. That is not a list of discoveries. That is a pattern, and the pattern is now too strong to ignore. Everywhere Juno looked for a boundary, it found continuity. Everywhere it looked for simplicity, it found lawful complication. Everywhere it pushed beneath appearance, it found structure that did not resolve neatly into the categories waiting for it. This is the midpoint where a weaker science script would try to reassure the viewer, yes, Jupiter is strange, but the mystery is being solved. The pieces are coming together. The deeper picture is becoming clear. That is only half true. The pieces are coming together, but what they are forming is not comfort. They are forming a new picture of Jupiter as a world organized less by clean divisions than by unstable transitions. Outer atmosphere into deeper fluid motion, molecular hydrogen into metallic hydrogen, compact core into diffuse heavy element region, local weather into planetary dynamics, interior dynamo into magnetospheric consequence, planet into system. And once you see that pattern, you begin to understand why Jupiter's moons matter so much. At first glance, the moons seem like a separate story, a family of worlds orbiting a giant planet. Interesting, beautiful, individually rich. But Juno makes it harder to keep them separate. If Jupiter extends itself into surrounding space through gravity, magnetism, radiation, and plasma. Then the moons are not merely nearby objects, they are embedded in the field of the planet's influence. They are places where Jovian power becomes geology, chemistry, fracture, heat, and in some cases the possibility of hidden oceans. That matters because it widens the meaning of what NASA found below Jupiter's clouds. What it found was not just a revised interior. It found a world whose hidden structure overflows its own visible body. And to feel the force of that, you have to begin with the most violent example in the entire Jovian system. A moon so stressed by Jupiter's pull that rock behaves like flesh under repeated strain. A world whose interior is being kneaded by gravity until it melts. A place where the planet's influence becomes eruption. Io is where Jupiter stops being distant and becomes physically brutal. Because Io is not just orbiting Jupiter. It is being worked on by Jupiter. That is the difference between a moon in the ordinary sense and a moon inside the full violence of the Jovian system. From far away, orbital motion can look clean, almost serene, small worlds circling a giant, each held in place by gravity, each following a path that can be drawn as an elegant line. But elegance at orbital scale can hide brutality at material scale. Io moves through that elegance like something under strain. Its orbit is stable enough to endure. Its interior is not calm enough to forget what holds it there. This is what makes Io one of the most revealing objects in the solar system. Not because it is merely volcanic, though it is the most volcanically active world we know. Not because it is visually dramatic, though sulfur plumes, lava lakes, and an ever-renewed surface give it a kind of infernal theatricality few worlds can match. It matters because Io is what Jupiter's gravity looks like when it stops being abstract. Up to this point, Jupiter's influence has been expressed through deep atmosphere, magnetic asymmetry, radiation, auroras, hidden interior structure. All of that can still feel, to the untrained imagination, like remote planetary physics, vast, elegant, difficult, but somehow still buffered by scale. Io removes the buffer. It takes the giant planet's invisible authority and converts it into heat, fracture, melt, eruption. It makes force visible in rock. And that is why Io belongs inside the core thesis of this story. Because what NASA found below Jupiter's clouds was not only a more complicated planet, it was a system in which Jupiter's hidden architecture spills outward and keeps rewriting nearby worlds. Io is the clearest proof. Its interior is heated not primarily by the slow decay of radioactive elements, as in many rocky worlds, but by tidal flexing. Jupiter's gravity pulls on Io with immense strength. But the pull is not perfectly constant in a way that would allow the moon to settle into complete stillness. Io is also locked into orbital resonances with Europa and Ganymede. Those resonances maintain a slight eccentricity in its orbit, preventing it from relaxing into a perfect circle. The result is cruelly elegant. As Io moves closer to and farther from Jupiter during each orbit, the strength and geometry of the tidal pull vary. The moon flexes. Its shape is continually distorted. The interior is kneaded. That word matters. Not squeezed once, not broken once, kneaded. Repeated strain becomes heat. Heat becomes partial melting. Partial melting becomes magma, ascent, eruption, resurfacing, over and over. So when you look at Io and see plumes rising hundreds of kilometers above the surface, or lava lakes with dark crusts overturning over molten interiors, or broad volcanic plains stained with sulfurous compounds in yellows, oranges, blacks, and reds. You're not just looking at local geology. You're looking at a moon whose internal state is being maintained by the relentless conversion of orbital mechanics into thermal violence. Gravity has become metabolism, not life, something colder. A system in which motion through a gravitational field is enough to keep a world geologically flayed open. This is why Io feels so important after everything Juno has already revealed. Jupiter's storms told us that visible weather can be the shallow edge of hidden depth. Jupiter's magnetic field told us the invisible interior can reach outward into space. Io now tells us that the reach of that interior is not merely electromagnetic or atmospheric. It is mechanical. Jupiter does not simply dominate its surroundings by mass. It physically works on them. It pumps energy into nearby worlds and leaves that energy written in lava. And Juno, though designed primarily to study Jupiter itself, was not blind to this wider pattern. During its extended mission, the spacecraft made close flybys of the Galilean moons, including Io, gathering observations that fed directly into this larger realization. It captured extraordinary views of the moon's tortured surface and active plumes, not as disconnected sightseeing, but as evidence that the Jovian system is one continuous field of consequence. The farther Juno went in understanding Jupiter, the harder it became to draw a satisfying line where Jupiter ended and the system around it began. Io is especially valuable because it destroys a comforting illusion humans carry about scale. We tend to think that things become less intimate as they become larger, that planetary systems should be majestic at a distance and abstract in their workings. Jupiter corrects that brutally. Here is a planet so large that more than 1,000 Earths could fit inside it, and yet its presence is not diffuse in effect. It is intimate in the harshest sense. Its pull reaches into a moon's body and forces that body to feel its orbit from the inside. That is an astonishing sentence when fully unpacked. Io does not merely move around Jupiter. It feels the orbit as pain translated into physics. Its crust fractures because of it. Its mantle melts because of it. Its volcanoes erupt because of it. Its surface cannot keep old scars because new fire is always arriving. On Earth, volcanism can feel deeply geological, something tied to the slow internal machinery of the planet itself. On Io, volcanism feels almost relational. The moon erupts because it lives where it lives, because the giant world beside it will not leave it mechanically at peace. That makes Io more than a volcanic moon. It makes it an exposed consequence of Jupiter's dominance. And dominance is the right word, not in the emotional human sense, but in the structural one. A planet so massive, so magnetically immense, so dynamically active, so surrounded by radiation and plasma, that its moons are not merely satellites, they are participants in its physics. That becomes even clearer when you consider Io's role in Jupiter's magnetosphere. The volcanic gases and particles blasted from Io do not simply disperse into empty space. They become ionized and trapped within Jupiter's magnetic environment, feeding the plasma torus around the planet and helping sustain electrical currents that connect moon and magnetosphere. So Io is not only being tortured by Jupiter's gravity, it is also feeding Jupiter's electromagnetic system. The moon's eruptions become material in the giant planet's field. Rock becomes plasma. Geology becomes circuitry. This is one of the most beautiful and severe ideas in the whole Jovian system. A moon erupts because of tidal stress. Its material escapes. That material is ionized. The ionized matter enters the magnetosphere. The magnetosphere helps shape the auroras. The auroras mark the outward behavior of the hidden interior. A line can be drawn from the blurred center of Jupiter to light above its poles through a moon that is continually being torn warm enough to erupt. That is not a collection of facts. That is architecture, and it clarifies something that might otherwise remain abstract. When we say Jupiter is a system organized by gradients and influence rather than neat boundaries, Io is one of the places where that becomes undeniable. There is no clean separation between planet and moon here. Different bodies? Yes. Different compositions? Yes. Different surfaces, histories, and local conditions? Certainly. But they are tied together by force so tightly that to explain Io properly, you must explain Jupiter, and to explain Jupiter fully, you must account for what it does to Io. The visible image of the moon carries the hidden logic of the planet. It also sharpens the emotional residue of the story. Until now, the revelations have been destabilizing in a cognitive sense. Fuzzy core, deep storms, asymmetric magnetic field, strange chemistry, severe auroras. The tension has come from the mismatch between what reality is and what intuition expected. Io adds something more physical. It shows that Jupiter's hidden structure is not only harder to classify, it is powerful enough to wound nearby worlds into new states. That matters because it turns mystery into consequence. Jupiter is not only strange for itself, it is strange in what it causes, and once you accept that, the rest of the Jovian system changes meaning too. The moons can no longer be treated as side characters orbiting the main event. They become different expressions of the same deeper pattern. If Io shows what Jupiter's pull can do to rock when it's too close and too strained, then Europa and Ganymede will show something equally important in quieter registers. what that same system can hide inside cold worlds that appear, at first glance, far more still. Because Jupiter does not only create violence, it also creates concealment. And that is the next escalation. After the molten exposure of Io comes a colder form of hidden depth, one that carries the logic of the whole story into ice, darkness, and the possibility of oceans sealed away from sight. Because the most unsettling worlds in the Jovian system are not always the loudest ones. Io announces itself in fire. Europa and Ganymede do something more dangerous to the imagination. They look cold enough to seem finished. From a distance, icy moons tempt us into a familiar mistake. A bright surface suggests dormancy, ice suggests stillness, a frozen shell suggests a world whose interesting history belongs mostly to the past. That intuition is not irrational. On Earth, ice often means arrested motion, preserved shape, slowed chemistry, reduced activity. We associate cold with quiet, and quiet with simplicity. Jupiter has a habit of humiliating that chain of reasoning. Because in the space around this planet, cold surfaces can be masks over deep interior unrest just as deceptive as Jupiter's clouds. If Io is the exposed wound of tidal heating, Europa is the sealed one, and Ganymede, larger and stranger still, shows that even size and apparent composure do not rescue a world from hidden complexity. This matters because it extends the central thesis of the entire story. What NASA found below Jupiter's clouds was not just a revised picture of one giant planet. It found a pattern. Visible surfaces across the Jovian system are repeatedly poor guides to the deeper truth. Clouds hide a fuzzy center, storms hide chemical transport, auroras hide magnetospheric architecture, ice hides oceans. Familiarity keeps breaking at depth. That is why Europa belongs here so naturally. Its surface is one of the smoothest in the solar system, bright with water ice, scored by long fractures, streaks, disrupted bands, and regions of chaos terrain where the frozen crust seems broken, shifted, and partially reassembled. To the eye, it already looks uneasy, but even that visible unease is only the beginning. The deeper significance of Europa is not its surface patterning by itself. It is what those patterns imply about what lies below. A global ocean of liquid water beneath the ice, maintained not by sunlight but by internal heating, much of it driven by tidal interaction with Jupiter and with the broader orbital dance of the Galilean moons. That idea alone has altered planetary science. For most of human history, oceans belonged almost by definition to the surface. They were exposed, wind-driven, illuminated, woven into weather and light. Europa offered a colder and more haunting possibility, a world where the ocean does not meet the sky at all, an ocean under a roof of ice, a hidden sea under darkness, pressure, and continuous mechanical influence from the giant planet nearby. And once that possibility is real, the moon stops being a frozen object and becomes a concealed system. This is where the logic of Jupiter's influence becomes clearer in a quieter key. On Io, tidal stress is so intense that rock melts openly. On Europa, the energy budget is lower, the surface colder, the expression more restrained, but the same underlying principle survives. Jupiter's gravity, modulated through resonance and orbital geometry, keeps working on the moon. Not enough to turn it into a volcanic inferno, but enough to flex its interior, generate heat, and help maintain liquid water beneath an ice shell that might otherwise have frozen through. Different distance, different composition, different consequence, same empire of force. That is what makes the Jovian system feel architecturally unified rather than merely crowded. Jupiter does not simply possess moons. It conditions them. Its gravity enters their histories, its field enters their environments, its system of resonances enters their interiors. Its presence changes what states of matter remain possible inside them. And Europa may be the most emotionally charged example of all, because hidden water has a way of reordering the imagination. Water is not life, but in human thought it is always close to the threshold of life. It carries chemistry, stability, mobility, possibility. A buried ocean, then, is not just a geophysical curiosity. It is a challenge to a deeply terrestrial intuition. That habitable complexity belongs near warmth, light, and open surfaces. Europa suggests that one of the solar system's most compelling oceans may exist under kilometers of ice, in a place where sunlight is weak, the surface is punishingly cold, and the real action happens out of sight. But even if one strips away all astrobiological excitement, the Moon remains scientifically severe, because Europa's fractures, ridges, and disrupted terrains imply exchange between surface and depth, between brittle shell and mobile underlayer, between visible ice and hidden oceanic motion. The surface is not merely old and cracked, it is being informed by what lies below. As with Jupiter, the visible layer is not separate from the hidden world. It is a record, distorted but real, of deeper processes pressing upward. That continuity is the deeper point. The script is not drifting away from Jupiter here. It is showing what Jupiter means when translated into another kind of world. If Jupiter's own clouds taught us that visibility can be shallow, Europa teaches the same lesson in a colder material. A bright surface can still be an obstruction. A fracture can still be only the edge of a deeper process. A moon can look frozen and still be internally dynamic enough to resist any easy label of deadness. And then there is Ganymede. If Europa is haunting because of concealment, Ganymede is haunting because it breaks expectation in too many directions at once. It is the largest moon in the solar system, bigger than Mercury, a world with enough scale to feel almost planet-like in its own right. Yet it orbits another planet and lives inside the Jovian system's larger field of consequence. For a long time, that alone made it conceptually strange. A moon large enough to deserve its own gravity-driven seriousness, but still subordinate to Jupiter's dominance. Juno added to that strangeness. During close flybys and extended mission observations, it helped deepen the sense that Ganymede is not a simple icy relic, but a differentiated, internally interesting world with a magnetic field of its own and growing evidence for complexity extending beneath the surface. Water vapor detections and improved observations of the moon's environment fed into a broader realization already building from prior missions. Ganymede is not just a block of ice and rock. It has structure. It has layering. It may contain a deep ocean sandwiched between high-pressure ice layers. It possesses its own miniature magnetosphere nested inside Jupiter's gigantic one, a magnetic world living inside a far larger magnetic regime. That nesting is one of the strangest images in the solar system if you let yourself feel it. A moon carrying its own magnetic field while moving through the overwhelming magnetosphere of a giant planet. One invisible architecture inside another. One protective bubble embedded in an empire of charged particles and force lines. It feels almost impossible as geometry, and yet it is simply what the physics allows. Again, the visible image is not enough. Again, the deeper reality is layered beyond intuition. Again, a clean category begins to fail. What exactly is Ganymede in the ordinary human sense? A moon, a protoplanet, an icy world with a hidden sea, a magnetic body inside another body's field? The answer is yes, and that is precisely the problem. Jupiter keeps generating worlds and structures that refuse the comfort of singular identity. That is why the moons matter so much for the final movement of this story. They are not digressions, they are confirmations. They prove that the pattern Juno found under Jupiter's clouds was never local. The pattern is systemic, across this entire family of worlds. Surfaces mislead, boundaries blur, hidden layers matter, and the giant planet's influence turns distance into consequence. Fire on Io, buried water on Europa, nested magnetism and deep structure on Ganymede. Different expressions, same deeper grammar. And the grammar itself is becoming unavoidable now. Jupiter is not best understood as a giant sphere with a few interesting companions. It is better understood as a regime of transitions. Gas into fluid depth into metallic conductivity, conductivity into field, field into radiation and aurora, gravity into tidal strain into melt, fracture, subsurface ocean, visible surface into hidden interior, planet into system. Once that pattern stabilizes in the mind, the original question, what NASA found below Jupiter's clouds, starts to mature into a different one. Not what was down there, but what kind of reality keeps producing these same humiliations of intuition in one form after another? That is the final pressure now. Because once a pattern repeats this many times, it stops feeling like a list of discoveries and starts feeling like a law of perception. Jupiter is not just strange in detail, It is strange in the same direction. Over and over, it keeps showing that what looks bounded is continuous, what looks settled is active, what looks superficial is deep, and what looks like a complete image is only the first negotiable layer of a much larger truth. And that means the ending can no longer be about one instrument, one orbit, one finding, or one moon. It has to be about the collapse of a more comforting model of reality itself. Because by this point, Jupiter is no longer just a destination in a mission profile. It has become an argument against the way human intuition wants reality to be built. That is the mature form of the story now. Not simply that Juno discovered surprising things. Surprise is cheap if it remains local. Science can survive local surprise very easily. A storm is deeper than expected. A field is stronger than predicted. A moon is more active than old models assumed. Those are important, but they do not necessarily rearrange the way the mind sees the world. Jupiter does something harsher. It keeps forcing the same correction across different layers of reality until the repetition itself becomes the revelation. The correction is this. What looks like a boundary is often a transition. What looks like a surface is often a leak. What looks like a stable category is often only a temporary convenience. What looks complete in images is often only the visible edge of a process still descending, or still spreading outward beyond sight. That is the real discovery below Jupiter's clouds. Not one object, not one mechanism. A pattern of failure in our old way of dividing the world. And what makes that pattern so powerful is that it does not arrive through philosophy first. It arrives through measurement, through radio shifts in a spacecraft's motion, through microwave emissions from hidden atmospheric layers, through magnetic mapping, through auroral behavior, through storm depth, through tidal consequence written into moons. Juno did not merely inspire a new interpretation of Jupiter, it cornered the old one until it stopped being enough. That is why the phrase gas giant starts to feel strangely inadequate here. The term is not wrong. Jupiter is overwhelmingly made of hydrogen and helium. It does not have a solid surface in the way Earth does. It is giant. But the phrase can also anesthetize the imagination. It makes the planet sound familiar in classification and therefore manageable in thought. A gas giant. Large version of a category. End of problem. Except Jupiter is not merely a big gaseous sphere. It is a rotating gravitational archive. A convecting interior whose structure may preserve and erase its own birth at the same time. A dynamo producing a magnetic field too asymmetrical to feel comfortably classical. An atmosphere whose storms are not skin-deep but anatomically deep. A chemistry lab operating under pressures and temperatures that rewrite what rain, hail, and lightning can mean. A system center whose influence does not stop at its visible body but enters the geology, oceans, and electrical environments of surrounding moons. At some point the classification stops helping. Not because it is false, because it is smaller than the reality it names. That is the recurring emotional effect of Juno at its best. The mission does not make Jupiter mystical. It makes it lawful in a way that feels less psychologically merciful. Nothing here escapes physics. Nothing requires vague reverence or fake wonder. The planet is obeying rules. The problem is that the rules, when allowed to operate at this scale, under these pressures, across these gradients, produce a world that no longer flatters the categories we formed under earthly conditions. In that sense, Juno is one of the great anti-anthropocentric missions. Not because it discovered aliens, not because it found life, not because it overthrew physics. Because it kept demonstrating that the universe can be fully lawful and still profoundly unintuitive. That is a subtler wound to human vanity. It is easy to accept that reality contains violence, distance, and scale beyond us. We have known that for a long time. What is harder to metabolize is that reality may also be organized in ways that do not naturally present themselves to minds shaped by surfaces, gravity wells, atmospheres, and temperatures like our own. We inherit a local intuition and then spend centuries discovering where it breaks. Jupiter is one of the clearest places it breaks beautifully. And what is beautiful here is not comfort. It is severity. The severity of a world that does not become simpler when approached. The severity of a planet whose hidden center is less bounded than the word center promises. The severity of storms that descend so far that weather ceases to feel like a layer. The severity of a magnetic field that reveals active asymmetry rather than elegant smoothing. The severity of moons that turn the giant planet's influence into lava, fracture, buried water, and nested magnetic worlds. All of it points toward the same matured realization. Jupiter is not organized by clean borders, it is organized by troubled transitions. That phrase is worth staying with, because it gathers almost everything Juno found into one deeper law. The cloud tops are a transition, not a surface. The atmosphere fades into deeper fluid behavior without the kind of line intuition wants. The outer molecular hydrogen gives way to metallic hydrogen under compression, but not in a way that the imagination experiences cleanly. The core, if that word still deserves to be used, may be a broad inner region enriched in heavy elements, rather than a sharply isolated compact center. The magnetic field rises out of conductive motion that does not average itself into the simple symmetry we hoped for. The magnetosphere blends planetary interior, rapid rotation, solar wind, and material from Io into one extended electrical domain. Europa's ice is not the end of Europa. Io's crust is not protection from Jupiter's pull. Ganymede's identity does not stop at Moon. Jupiter keeps replacing nouns with gradients. And that may be the deepest reason the planet feels so intellectually powerful. It exposes how much human understanding begins by cutting the world into named pieces, then slowly discovers that reality often reserves its most important behavior for the spaces between those pieces. We speak of atmosphere and interior. Jupiter gives us dynamic continuity. We speak of core and envelope. Jupiter gives us dilution and transition. We speak of planet and surrounding space. Jupiter gives us a magnetosphere that is part consequence, part extension, part environment, part outward confession of the hidden inside. We speak of planet and moon as if those were fully separate explanatory units. Jupiter gives us a system where gravity, particles, tides, and fields keep writing one body into another. That is the point where the mission's science crosses quietly into philosophy without ever abandoning rigor. Not because it tells us some grand mystical lesson, but because it reveals that the structure of explanation itself has to mature. The more deeply we look, the less likely we are to find the universe divided along the same lines our first impressions drew. And once you see that on Jupiter, you start to suspect it elsewhere. Maybe not always in the same form. Not every world is Jupiter. Not every atmosphere becomes a planet-sized fluid descent. Not every moon hides an ocean. Not every magnetic field sprawls into an empire of trapped radiation. But the general warning survives. A visible surface is not a promise of conceptual accessibility. A famous image is not a guarantee of understanding. Better measurement does not always preserve the old architecture with better numbers. Sometimes it dissolves the architecture. That is one of the noblest things science can do. Not merely add facts, but teach the mind where its inherited shapes are too crude. Juno did that repeatedly. It did it with the core, it did it with the winds, it did it with the field, it did it with the chemistry, it did it with the poles, it did it indirectly and then directly with the moons. And now there is a final emotional turn still left to make, because all of this could be heard as intellectually bracing but emotionally distant. A triumph of planetary physics, yes. A correction to human intuition, yes. But why should that linger after the last line? Why should the viewer feel anything more than admiration for the science? Because Jupiter does something rare in modern knowledge. It restores consequence to truth. Not consequence in the sensational sense, and not danger to us, and not apocalypse. Something quieter and more lasting. It changes what a world is allowed to be in the imagination. Before Juno, Jupiter could still live there as a majestic object, enormous, beautiful, iconic, violent in broad outline but conceptually containable. After Juno, that containment becomes much harder to maintain. The planet remains iconic, but the icon starts leaking. The stripes no longer sit easily on the mind. The great red spot no longer reads as merely a great storm. The auroras no longer feel like atmospheric ornament. Even the phrase below the clouds no longer means what it seemed to mean at the start. Because there is no simple beneath waiting there. There is only a descent into deeper continuity. And continuity is, in some ways, stranger than hidden chambers or clean-buried secrets. Secrets can be uncovered. Chambers can be entered. A continuity that keeps dissolving your categories as you follow it downward is harder to satisfy. It does not produce the emotional closure of discovery in the heroic sense. It produces something colder. a form of respect. Respect for the fact that reality may be structured more severely than beauty suggests. Respect for the fact that large-scale truth is often not where intuition wants to stop. Respect for the possibility that understanding a world means giving up the right to imagine it in the old easy way. That is where the ending has to go now. Not toward summary, toward afterimage. Back to Jupiter itself, but not the Jupiter from the beginning. Not the recognizable sphere in a textbook or telescope eyepiece. Not the striped giant that looked almost understandable from far away. The one that remains after the categories have been damaged. The one Juno leaves behind. The Jupiter that remains is harder to picture, even after all the images. That may be the most honest measure of what Juno achieved. We are used to thinking that knowledge makes an object more familiar, more precise, certainly, but also more settled in the mind. First there is mystery, then investigation, then a sharper and more stable image, science, in its most popular retellings, is often made to feel like a slow conversion of darkness into clarity. Jupiter did not quite allow that. Juno gave us clarity, yes, but not the comforting kind, not the kind that leaves the object smaller and the categories stronger. It gave us a harsher clarity, the clarity of realizing that the planet had never really matched the forms we were quietly imposing on it. The clouds were not the surface we imagined. The storms were not a layer of behavior floating over a separate inner truth. The center was not cleanly central in the old compact sense. The field was not elegantly smooth. The chemistry was not simply atmospheric. The system was not neatly divisible into planet here, moons there, space around both. The knowledge became better. The picture became less humane. That is not a failure of science. It is one of its highest successes. Because a serious encounter with reality should sometimes leave us with fewer illusions, not just more information. And that is why Jupiter lingers so differently after Juno, not merely as a giant planet, not merely as the largest world in the solar system, but as one of the clearest demonstrations that the universe does not have to be chaotic to feel severe. Law is enough. Pressure is enough. Time is enough. Rotation, composition, gravity, conductivity, resonance, those ingredients, given enough scale, are sufficient to produce a world that disobeys the psychological expectations we bring to it without disobeying a single physical principle. There is something almost coldly beautiful in that. No conspiracy, no cosmic message, no mystical exception, just a planet obeying reality more fully than our intuitions can easily follow. That is what gives Jupiter its final power. It is not merely strange, it is lawful in a way that makes strangeness unavoidable. And once you see that, the famous visual image of the planet changes forever. The bands become less like stripes and more like the uppermost handwriting of deep flow. The great red spot becomes less like a symbol, and more like a wound in a fluid body too vast for terrestrial comparison. The auroras become less like decoration, and more like exposed circuitry. Even the clouds themselves lose their old innocence. They are no longer a picturesque shell. They are the bright visible interruption where human eyesight ends and the more consequential Jupiter continues without it. That is the deeper answer to the title. What NASA found below Jupiter's clouds was not simply a hidden layer or a buried object. It found that below was the wrong emotional model from the beginning. Because below suggests a clean hierarchy. Surface first, truth afterward, appearance on top, reality underneath. Jupiter offered something less convenient. Not surface and secret, but visible trace and deeper continuity. Not a mask hiding a simpler face, but a visible face already shaped by processes extending far beyond what vision can hold. Not a world with a mystery tucked beneath it, but a world whose every attempt at explanation opens into larger connected structure. That is why the mission keeps widening even in hindsight. The fuzzy core is not only about the core, it is about whether origins remain legible in the forms we expect. The deep winds are not only about meteorology, they are about whether weather can still be separated from planetary body. The magnetic asymmetry is not only about field geometry, it is about whether hidden mechanisms average themselves into elegance. The ammonia, water, and lightning are not only about chemistry. They are about whether familiar physical ingredients still behave familiarly under alien conditions. Io is not only about volcanism, Europa is not only about subsurface oceans, Ganymede is not only about a moon with a magnetic field. Each one is another instance of the same correction. The visible world is not the whole world. The named category is not the full behaviour. The boundary is rarely where intuition wants to put it. Juno did not just teach us this about Jupiter. It taught it in one of the purest ways science can teach anything, by forcing the correction again and again until the mind has no graceful way to keep its older simplification alive. That repetition is why the mission feels larger than a list of results. A list can be admired and forgotten. A repeated correction can become part of how you see, and once it does, Jupiter stops being a destination story and becomes a discipline of perception. A reminder that reality is often not hidden because it is far away, but because we begin with the wrong expectations about what understanding should look like when we arrive. We expect depth to mean closure. Sometimes depth means the loss of closure. We expect better instruments to reveal cleaner things. Sometimes better instruments reveal that the cleanliness belonged to us. We expect the hidden structure of a world to justify the image we already had of it. Sometimes the hidden structure quietly invalidates the comfort of that image. This is why the final feeling Juno leaves behind is not triumph in the simple sense. The mission was a triumph, unquestionably, technically, scientifically, imaginatively. A solar-powered spacecraft crossed the solar system, entered orbit around the largest planet we know nearby, survived radiation intense enough to cripple unshielded electronics, repeatedly skimmed above cloud tops, mapped gravity, magnetism, chemistry, storms, auroras, and moons, and kept returning with discoveries that changed planetary science. All of that is extraordinary. But the emotional residue is subtler. Not victory over Jupiter. Respect for the fact that Jupiter was never obliged to become conceptually comfortable just because we finally had the tools to measure it well. There is dignity in that, and maybe even a kind of relief. Because one of the quiet dangers in knowledge is the fantasy that enough measurement will make reality feel tame. That once the data is good enough, the universe will begin to resemble our diagrams not only mathematically but emotionally. Jupiter denies that fantasy without denying science. It remains measurable and still difficult, explainable and still severe, more known and still less assimilable. That combination is rare. It is why the planet now feels older than its image, older than the red spot in posters and textbooks, older than the clean phrase gas giant, older than the first glance that tells a child or an adult alike, "I know what that is." No, you know what it looks like. Juno was sent to press past that first mistake, and in doing so, it discovered something larger than a hidden feature below the clouds. It discovered that Jupiter is one of the places in our solar system where reality most clearly exceeds the emotional scale of the words we use for it. Planet, atmosphere, core, storm, moon, all still correct, all no longer sufficient. That insufficiency is not frustrating in the shallow sense. It is the source of the afterimage, because it leaves Jupiter in the mind not as a solved object, but as a lawful excess, a world whose truth cannot be reduced to the visible form that made it famous, a world whose beauty is no longer separable from the way it dismantles simplification, a world that, even after one of the most successful planetary missions of the modern era, still feels not vague but deeper than the categories carried to meet it. And perhaps that is the most mature answer Juno offers, that the universe does not always reward deeper looking with neater reality. Sometimes it rewards deeper looking with truer difficulty. Sometimes the deeper layer is not a hidden chamber waiting to be lit. Sometimes it is the place where your old architecture of understanding begins to come apart. That was what stood below Jupiter's clouds. Not emptiness, not a single secret, not a clean final picture. A descent into a world built from gradients, continuities, and consequences vast enough to humble the eye that first believed it was looking at a striped sphere. And somewhere above those clouds, pass after pass, Juno kept moving through weak sunlight and invisible violence, listening to gravity, tracing magnetism, watching storms, crossing the poles, widening the truth without forcing it into comfort. It did not make Jupiter smaller. It made our first idea of Jupiter impossible to keep. That is the real discovery. And once you have seen that, the planet never really closes again. And that may be the most enduring gift of a mission like Juno, not that it leaves us with a final image, that it ruins the old one so completely that we can no longer mistake recognition for understanding. There is a difference between seeing a world often and seeing it truly. Jupiter had been seen for centuries, through backyard telescopes, through observatory glass, through the brief revelations of flyby missions, through paintings, diagrams, school books, spacecraft mosaics, and the easy shorthand of culture. Of all the planets beyond Earth, it may have seemed one of the most visually legible, a giant, banded sphere, an unmistakable object, a world with character so strong it almost felt self-explanatory. That was always a dangerous form of familiarity, because familiarity can become one of the most efficient ways of not thinking deeply enough. Once the image stabilizes in the culture, the mind stops pressing against it. Jupiter becomes not a question, but a symbol, not a system of active unknowns, but a place already emotionally filed away as understood in broad outline. Large planet, strong storms, big magnetic field, many moons, all true, all insufficient. Juno's deeper achievement was to make insufficiency visible, not by replacing those truths with their opposites, but by making them heavier, harder, less easily carried in ordinary language. Yes, Jupiter has storms, but some of those storms descend into a body whose distinction from atmosphere is no longer clean. Yes, Jupiter has a magnetic field, but that field is not merely immense, it is structurally irregular enough to expose unresolved complexity in the hidden dynamo beneath it. Yes, Jupiter has a core, perhaps, but not one that preserves the old comfort of compact central certainty. Yes, Jupiter has moons, but those moons are not simply orbiting companions. They are expressions of Jovian force in different materials, fire in one place, buried water in another, nested magnetism in a third. This is what mature knowledge often does. It does not strip away mystery. It strips away shallow ways of containing it. And that may be the right note to hold here, because there is a temptation, especially in science storytelling, to treat the final act as a place of conceptual tightening, a place where the discoveries are gathered neatly, arranged into a satisfying stack, and offered back to the viewer as a clarified whole. Jupiter resists that ending too, not because the science failed, because the science succeeded. A successful encounter with a world like Jupiter should not leave you with the emotional impression that everything has clicked into place. It should leave you with something more disciplined than wonder, and more honest than closure. A sense that the object is now better known and still not mentally exhausted. That the truth has become sharper, and, in becoming sharper, has also become less willing to fit inside the easy image that first introduced it to you. There is real value in that discomfort. It protects science from turning into decoration. A lesser story about Jupiter would let the planet remain picturesque even after the facts are updated. It would let the discoveries operate like annotations around a familiar icon. The stripes stay the stripes. The red spot stays the red spot. The gas giant stays the gas giant. A few interesting additions accumulate, but the basic emotional object remains untouched. Juno did not permit that. The stripes are no longer just stripes. They are the visible edge of deep, fluid motion. The red spot is no longer just a famous storm. It is a long-lived vortex embedded in a planetary body whose weather cannot be cleanly separated from hidden depth. The auroras are no longer just beautiful emissions. They are electrical consequence written into light by an interior whose activity extends outward into space. Even the phrase gas giant becomes difficult to say with a straight mind once you have really followed the descent. The gas is real. The giant is real. But the phrase leaves out too much of what now matters: the conductive depths, the diluted center, the asymmetrical dynamo, the chemistry under pressure, the moons as consequences, the whole system as a network of exchanged force. Jupiter has not outgrown the label. It has simply become too large for the label to feel like comprehension. That is the shift the viewer should carry now. Not the childish thrill of Jupiter is crazy. Not the thin educational satisfaction of I learned new facts. Something quieter, more durable. The sense that the world is built more deeply than appearances train us to expect. That may sound broad, but here it has been earned specifically. Every major step in the descent has reinforced it from a different angle. The cloud tops failed as a boundary. Gravity failed to preserve a neat center. Magnetism failed to preserve smooth hidden order. Storms failed to remain superficial. Chemistry failed to remain familiar. The system failed to remain divisible, and each failure was productive. Each one forced a better account. Each one widened the meaning of what a planet can be. That is why Jupiter no longer feels, after Juno, like a giant object sitting out there at a distance. It feels like a place where several of our favourite simplifications go to die. And that, strangely, is part of its beauty. Not sentimental beauty, not decorative beauty, a more severe kind. The beauty of a world that remains lawful while exceeding the emotional range of the concepts first used to hold it. The beauty of a planet that does not become mystical when understood more deeply, but becomes more exacting. The beauty of a system where force leaves signatures across scales so different that clouds, fields, ice, lava, plasma, and ocean all become chapters in the same physical argument. That argument is not finished. Of course. Juno has not said the last word on Jupiter. No serious mission ever truly says the last word on a world this large. There are still questions about the precise structure of the deep interior, the dynamics of the Dynamo region, the full distribution of water and heavy elements, the long-term evolution of the atmosphere, the mechanics of storm persistence, the interaction between magnetosphere and moons, the histories buried inside the current measurements. A planet like Jupiter does not surrender to one mission, however transformative. But there is a difference between unfinished science and incomplete seeing. Before Juno, much of Jupiter's unfinished science still lived inside an image that felt emotionally settled. After Juno, even the unfinished parts have a different shape. They are no longer gaps in a basically comfortable picture. They are openings in a reality already known to resist comfort. That changes how future knowledge will land. Every new result now arrives in the shadow of a harder lesson. That deeper access does not guarantee simpler truth. It may only reveal that the simplicity was our own projection. That lesson is not limited to Jupiter, but Jupiter may be one of the cleanest places to feel it. And perhaps that is why the mission feels so large in retrospect, not merely because of what it discovered, but because of the kind of discovery it was. Some missions extend a map, some missions test a theory, some missions deliver stunning images. Juno did all of that, but at its highest level, it also performed a correction of perception. It taught us that a world can be iconic and still conceptually underread, familiar and still unassimilated, beautiful and still structured in a way that does not flatter the habits of the eye. The more serious the viewer becomes by the end, the less they should feel like they are looking at Jupiter the way they used to. That is the right residue. Not confusion, not summary, a changed relationship. The next time that striped sphere appears, on a screen, in a photograph, in a child's textbook, in a telescope view through moving air, it should no longer feel like a finished image. It should feel like a threshold, an invitation into gradients, buried transitions, electrical asymmetry, tidal consequence, hidden water, fluid depth, and a kind of lawful severity our first glance could never have carried. That is what Juno gave us. Not the satisfaction of having finally seen beneath Jupiter's clouds. The realization that seeing beneath them means entering a world where beneath is no longer a simple direction, and where the truth does not wait in one clean hidden place. It waits in the collapse of the old divisions. And once that collapse is understood, even partially, Jupiter changes category forever. It is no longer just the largest planet in the solar system. It is one of the clearest demonstrations that reality can be more connected, less bounded, and more exacting than the visible world first suggests. That is not a small upgrade in knowledge. It is a shift in what knowledge feels like. And it leaves us with one final image, not because the story needs a tidy ending, but because the mind needs somewhere to stand after a descent like this. A spacecraft crossing above the poles of Jupiter. Below it, cloud systems churning over depths no eye can reach. Around it, a magnetic empire alive with trapped particles and invisible force. Farther out, moons carrying fire, fracture, ocean, and ice under the pressure of the same giant influence. And everywhere, the same lesson repeating in different materials. What appears separate is connected. What appears shallow is deep. What appears settled is still in motion. What appears understandable is only the beginning of understanding. Juno did not discover that Jupiter was strange. It discovered that our first way of being comfortable with Jupiter was false. And the moment that comfort gives way, the planet becomes what it always was. Not a picture, but a reality. And a reality does not owe us neatness. That is the last discipline Jupiter imposes. Human beings are very good at turning the world into manageable nouns. We have to be. Language survives by cutting continuity into pieces: planet, atmosphere, core, field, storm, moon, ocean, space. Each word is useful because it draws a line. Each line lets thought begin. Without those cuts, the world would be too fluid to handle. But Juno's long descent through the Jovian system showed, again and again, that reality often does its most important work before or beyond those cuts. Not in the noun, but in the transition. Not in the object as first named, but in the gradient the name only partly captures. That is why Jupiter feels so intellectually severe after the mission. It is not that the words became wrong. It is that the words became visibly provisional. Take atmosphere. On Earth. The term comes with an instinctive structure, a gaseous layer over a planet. Weather happening above a more clearly bounded body. Jupiter begins with that appearance and then slowly strips the comfort out of it. The atmosphere is not just a shell, it is the upper visible portion of the motions reaching thousands of kilometers downward. Chemistry is being sorted through it. Lightning is flashing in altitudes where Earth-based intuition starts to fail. Rain does not simply rain. Storms do not simply pass. The atmosphere is not outside the planet in the emotionally easy sense. It is one mode of the planet's body. Or take core, a clean word, almost too clean. It promises a centre that remains itself, a compact answer at the point where questions narrow. But gravity forced a colder possibility into view, that Jupiter may preserve heavy material centrally without preserving a sharply bounded compact core at all. Not no centre, exactly. Something worse for the imagination. A diluted centre, a central region rich in heavy elements and blurred outward into the surrounding world. The reality remains physical, measurable, modelable, but the old emotional certainty carried by the word begins to drain out of it. The same with magnetic field, a phrase that sounds almost diagrammatic until Jupiter turns it into planetary consequence. A field large enough to dominate surrounding space, asymmetric enough to resist simple smoothing, alive enough to vary over time, tied to conductive depths, rapid rotation, plasma from moons, and auroras severe enough to look less like ornament than exposed circuitry. The field is not a tidy halo around the planet. It is one of the ways the hidden interior refuses confinement. And then moon, perhaps the most innocent word of all. A moon is supposed to be a secondary thing, a dependent body, a satellite, smaller, quieter, orbiting the main event. Jupiter breaks that simplicity in multiple directions. Io is not quiet. Europa is not closed. Ganymede is not just a moon in any easy sense. Each one becomes a different medium through which Jovian power is translated. Rock into lava, ice into hidden ocean, magnetic subworld into a larger magnetic regime. The moon remains a moon. But the word no longer feels like the end of explanation. It becomes only the start of a deeper one. That is the broader significance of Juno's discoveries when viewed together. They did not just refine our data about Jupiter. They exposed how much of understanding depends on learning when our categories are helping, and when they are merely comforting. That distinction matters far beyond one planet, because the danger in science is not only ignorance, it is premature familiarity. The moment an object becomes iconic, the mind starts conserving effort around it. It says, I know this in essence. I may not know every detail, but the basic image is secure. Jupiter had become one of those objects, famous enough to feel settled, distinctive enough to feel already possessed by culture, large, banded, stormy, magnetized, moon-rich, a known unknown perhaps, but known in the broad human sense. Juno damaged that feeling in the most constructive way possible. It showed that broad human knowing can be structurally shallow. That is one of the highest services a scientific mission can perform, not just adding detail to an already valid mental picture, but revealing that the picture itself has been too flat for the thing it claimed to contain. And once that happens, even the visible image changes moral weight. Look again at Jupiter after Juno and the old easy legibility is gone. The bands are no longer just coloration. They are signatures of deep flow. The cloud tops are no longer a surface. They are a threshold where the eye loses authority. The great red spot is no longer merely a giant storm. It is a long-lived vortex inside a fluid body too deep to map by instinct. The poles are no longer curiosities hidden from old viewing angles. They are proof that the familiar planetary icon never showed the whole emotional truth. The auroras are no longer just beauty. They are consequence, interior motion externalized into light through a magnetic empire stretching far beyond the visible globe. Even the phrase below Jupiter's clouds becomes almost tragic in retrospect. Not because it was wrong to say it, because it was too simple to survive success. At the beginning, the phrase sounds clear. There are clouds. Beneath them lies the hidden planet. Juno will tell us what is there, but by the end, beneath no longer feels like the right word. It implies a one-time crossing, a movement from exterior illusion into interior truth. Jupiter gave us something more demanding, a connected descent through layers that do not separate cleanly, through structures that preserve and erase history at once, through gradients where what appears visible is already shaped by what remains unseen. The truth was not sitting in one buried chamber. It was distributed. That may be the single hardest idea in the whole story, because a distributed truth does not satisfy the imagination the way a hidden object does. A hidden chamber can be opened, a buried core can be pointed to, a final answer can be circled. Distributed truth forces a more adult relationship to knowledge. It asks the mind to hold multiple linked realities at once: blurred core, deep winds, active dynamo, chemical transport, severe auroras, tidal systems, hidden oceans, system-wide consequence. No one part alone is the answer. The answer is the pattern they form together. And the pattern, by now, is unmistakable. Jupiter is a world where visible surfaces repeatedly fail to mark the real limits of things. A world where boundaries soften into transitions. A world where depth increases connection rather than separation. A world whose hidden structure overflows its own body and continues outward through fields, radiation, tides, and moons. A world that becomes more exact the more it becomes less intuitively containable. This is why the emotional residue at the end should not be loud awe or generic wonder. It should be something quieter and sharper, a kind of chastened clarity, the feeling that reality has not become mystical, only less obedient to the shortcuts we once used to imagine it, the feeling that the universe does not need to break its laws to break our confidence. It can do that simply by following those laws more fully than our local instincts prepared us to understand. Jupiter is one of the purest examples of that in the solar system. It does not scandalize physics, it scandalizes intuition. And intuition, once scandalized enough times by the same object, begins to mature. That is the hidden gift inside this entire story. The viewer who reaches this point is no longer just holding a more updated model of Jupiter. They are holding a more disciplined relationship to appearance itself. A surface may be real and still not be the right place to stop. A word may be correct and still not be large enough to contain the behavior it names. A better measurement may not save the old architecture of thought. It may reveal that the architecture was temporary from the start. That lesson is not depressing. It is liberating in a severe way, because it means the universe is still capable of being truer than the first forms we used to meet it. Juno was built for measurement, but what it finally delivered was a change in proportion. It rescaled our confidence. It reminded us that a world can be famous and still underread, beautiful and still conceptually punishing, lawful and still difficult to emotionally assimilate. It took an object that had become culturally overfamiliar and returned to it the dignity of difficulty. And perhaps that is the right way to prepare for the last turn, not by trying to solve Jupiter one final time, but by admitting that the mature reward of this mission is not closure. It is a new inability to look at the planet innocently ever again, because innocence depended on distance. From far enough away, Jupiter could remain an image, a striped giant, a red storm, a bright planet in the night sky, a textbook emblem of scale. Distance made that possible. Not just physical distance, conceptual distance, the kind that lets the mind accept a surface as a summary, a label as an understanding, a famous picture as if it were already a form of possession. Juno closed some of that distance, and in doing so, it did something more unsettling than simply revealing hidden features. It exposed how much of our old relationship to Jupiter had been based on the privilege of not having to know it too precisely. That privilege is gone now. The planet can still be admired from far away. It can still be loved as one of the great visible presences of the solar system. Its bands still carry beauty. The great red spot still looks like one of nature's most improbable signatures. The moons still move around it with the old elegance of celestial mechanics. None of that disappears. What disappears is the ease. The ease of believing the image is enough. The ease of thinking the clouds are a lid over something cleaner. The ease of hearing words like atmosphere, core, field, storm, moon, and feeling that the reality beneath them remains proportionate to the language. After Juno, Jupiter is still beautiful. But it is no longer simple enough to be beautiful in the old way. Now its beauty is tied to the damage it does to simplification. That is the mature end of this descent. Not that we reached the bottom, we did not. Not that the planet surrendered its final structure. It has not. Not that every open question closed into a finished map. It never will. The ending is more severe than that. We learned enough to lose the right to imagine Jupiter as a neatly bounded thing. That is what NASA really found below the clouds. Not a single secret hidden under a surface. It found a world whose visible face had taught us the wrong emotional lesson. It found that the cloud tops were not a boundary, but an interruption, that the atmosphere was not an outer layer in the comforting sense, but part of a descending planetary body, that the center was not a compact final answer, but a region where even the word core begins to fray, that the magnetic field was not a tidy surrounding feature, but the active outward confession of a hidden interior that does not smooth itself into elegance for our sake, that storms were not weather sitting on top of the planet, but deep motions revealing how little separation exists between appearance and structure, that lightning, ammonia, water, and slush-like hail were not atmospheric details, but clues to a chemistry operating under conditions too alien for Earth's instincts to trust themselves, that the auroras were not ornament, but impact points where the planet's hidden architecture announces itself in light, that the moons were not secondary decorations, but different materials in which Jupiter's influence keeps becoming visible, as fire, as fracture, as buried sea, as nested field, as tidal consequence written into matter. Piece by piece, the old Jupiter died. Not the real one, the one we could carry too easily. And that is why the mission lingers after its measurements, after the images, after the diagrams, after the headlines. Because a mission becomes unforgettable when it changes not only what we know, but what kind of knowing is no longer possible afterward. Before Juno, you could still see Jupiter as a giant object with interesting features. After Juno, that becomes much harder. Now it feels like a continuity too large for the eye. A world whose truth is distributed through depth, motion, asymmetry, pressure, chemistry, magnetism, and consequence. A world where the visible is real, but never final. A world whose hidden structure does not sit politely underneath the surface waiting to be extracted, but keeps reaching upward into the clouds and outward into space and sideways into the lives of its moons. That is why the phrase below Jupiter's clouds ends here with a different meaning than it began with. At first it sounded like a direction. Now it sounds like a warning. Go deeper, and the old divisions may not survive. Go deeper, and the hidden truth may not be cleaner than the visible one. Go deeper, and knowledge may not simplify the world. It may only make the world harder to dishonor with easy images. There is something almost austere in that. No final chamber, no glowing central revelation, no cinematic object waiting in the dark for the camera to find it. Only a planet becoming more exact and less containable as each instrument does its work. Only science succeeding so well that the reward is not comfort, but a truer difficulty. And perhaps that is why Jupiter now feels larger than before, even though we understand it better. Not larger in kilometers, larger in meaning. Because the familiar striped sphere no longer ends where it appears to end. It descends into gradients of pressure and conductivity. It rises into aurora and radiation. It extends through tidal force into molten rock and hidden water. It reaches into categories and leaves them useful but wounded. It remains one object in the sky. Yes, but one object whose reality spills beyond every easy frame that first made it famous. That is a rare achievement for any scientific mission. To return an object to reality after culture has turned it into an icon. Juno did that to Jupiter. It gave the planet back its difficulty. And so the final image is not one of resolution, but of permanence without innocence. A spacecraft passing over the poles of a world that never became cleaner when approached. Below it, clouds moving over depths where the old language fails by degrees. Around it, invisible fields shaping violence and light. Farther out, moons carrying the same giant influence into eruption, fracture, ocean, and ice, and holding all of it together, not mystery in the cheap sense, but law operating at such scale, under such pressure, through such strange transitions, that the lawful result feels almost harsher than mystery would have. Jupiter is still there tonight, if the sky allows it. Bright, striped, recognizable. But that recognition is no longer the same thing it was. Now, when you look at it, you're not really looking at a giant sphere with clouds. You are looking at a place where surface and depth stopped behaving like opposites. A place where the hidden world did not resolve the visible one, but overflowed it. A place where understanding did not make reality gentler, only more exact. A place where the universe, without breaking a single law, revealed how inadequate our first comfort with it had always been. That is what NASA found below Jupiter's clouds. Not a final answer. A planet too real for the old picture to survive.